Climate Change Department of Ecology, Environment and Remote Sensing, Government of Jammu and Kashmir, India. He has done his PhD from Center for Climate Change Water Research, Gyan Vihar University, Rajasthan, and MTech in Remote Sensing and GIS from SRM University, Chennai. He also did his MSc in Ecology and Environment from SM University, Gangtok. He has more than 12 international publications, 10 national level journals, 5 book chapters, 10 scientific reports and monologues, and 4 books. Also, he is selected for a United Nations Framework Convention on Climate Change in 2018, national level master national level master trainer in climate change vulnerability assessment, national e-government award 2012 2013 by Government of India, Young Scientist Award in 2010 by JNK Academy of Sciences, member of Indian Society of Geomatics, member of Indian Society of Remote Sensing, member of Indian Ecological Society. Sir, we are very delighted to have you here, and please start with your session. Thank you, sir.
Thank you very much, Upasna. Good afternoon, everyone. I would like to thank Dr. Shruti Kanga ma'am and Dr. Suresh sir for giving me the opportunity to actually to showcase some of the technicalities involved in QGIS. Actually, my presentation would be related to QGIS, though not practically, but it will be in a PPT mode. And after the PPT mode, we will hand over it to the our technical team, who will be ready with the practical portion from it. So in my PPT, I will be going through I will be going through the slides, just showing the functionalities. What are all the things, because this is an introductory session, introduction to QGIS, how QGIS looks, how the tools are there, what are the things that we can find in QGIS, what are the processes we can do in QGIS. So I will be just briefing about through slides. So what are the functionalities and what are the buttons extra available to us in QGIS. So I will just share my PPT. Is my PPT visible?
Yes, yes,
Yes, sir.
visible.
Yes, sir.
So, just to begin with, we'll have an introduction to quantum GIS. QGIS is actually known as quantum GIS. So, if we see here, there are two website names given here. One is QGIS.org. One is www.qgis.org and another one is www.osgeo.org. So from both the websites, whenever you see this type of icon, so this means that you can download the quantum GIS from these resources. So Hello, hello.
Yes, sir.
Yeah.
Yes.
Actually, I got disconnected. I'll just share again. So, about the introduction to quantum GIS, just I told before that we have QGIS and OSGeo sites. So we can see this icon and we can immediately download the software from these two websites. Now, looking over the overall agenda of my PPT, if we see what we are trying to cover in my PPT, though this is not actually the practical part, but this will give you a know-how. This will give you an understanding of different tools. Say, for example, my lab assistant, one who will be showing the practical portion after my lecture, he will be saying zoom to this layer, open this data. So you should know the buttons, you should know the overall look of GIS. So I will introduce to quantum GIS, then vector data, raster data, plugins, fields, attributes, creating data, map, layout, only through the software mode. So no theoretical part, nothing else. So I will be just showing the slides on QGIS. From yesterday, we have been hearing that Geographic Information System (GIS). It's a set of tools. I remember it with the simple definition. We use custard in home, custard. But here, we will remove the u term from it, and we see custard. So we see create, analyze, store, transform, retrieve, and display the data, geographically referenced data. Whatever is available with us data in the form of geographically referenced. Say, for example, we have a map or a plan or an architectural structure available with us. So if we see that and we try to analyze that, and it is without geo coordinates, we cannot say it is a GIS. We have to have the geographically referenced data or GPS points, which should be associated with that map or with that plan. Only and then we can tell this is a geographic information system. Now, where is this GIS used? During the course of this series of lectures in the 21 days, you will be seeing that this is used in a number of applications in the municipalities, in forestry, in military, in commercial business, in urban sector, in agriculture sector. So, any number of it's just we say that the applications of remote sensing and GIS are limited to our imagination only. So what do you do with it? Basically, what do we do with the help of GIS? We plan things, we know things. For example, I will give you a very simple example. You have the Google Map in your mobile phone. So if you're coming to Jaipur, and in Jaipur you have to go to Gyan Vihar University. So whenever you come, when you come off a train or a plane, what will you do immediately? If you don't know the location, you will ask your Google Map that I am right now here and I want directions to Suresh Gyan Vihar University. Immediately Google Map or this app, it will immediately give you the directions that are required. Even it will give you two or three possible directions, and it will give you the timings when you are going to reach that place. It will show you the routes which you can take to that place. So that's GIS, that is Geographic Information Science behind that app, that tells you that how to go from this location to another location. And please mind it that I'm using the word location. Location is georeferencing, geographically referenced data. Only when it has the location, it can calculate the time required from going from this point to that point. So when we have these coordinates fixed, only then it calculates the time to be taken for the distance between these 2 points. So it's actually planning. We planned our trip from airport to Suresh Gyan University with the help of that small application. Similarly, there are n number of applications in forestry, in urban sector. As I told, what you can do with the help of GIS. In GIS, अगर हम मोटा मोटा बात कर लें कि छोटा मतलब very very simple applications, we can easily measure the distance between the 2 points. We can measure the polygon, we can measure the area. For example, our house is there and somebody comes and say no, you have taken the area of my house. What you do, you go immediately on the Google Earth, or you use your mobile phone and you go to the field, and you just walk around that area and you calculate, okay, this is my area of my house, and easily measure the distances. For example, I have to go from Jaipur to Janwihar University. I already gave the example, but here you can measure the distances with the help of GIS also on screen, just sitting on your laptop and just click with the help of just few clicks, you will be easily able to calculate the distance required for from airport to the Janwihar University, or the railway station to Janwihar University. Then you can find the overlap between the features. For example, there is a water body and there is an agricultural land, and these two features have been digitized separately and they are now sitting on each other. So you can, with the help of this GIS, you can find that overlap and you can easily see the roads that are going through the agricultural lands. You can see the flowers which is overlapping the road below. So there are n number of functionalities associated with the geographic information system. Another very important thing is proximity. In fact, I am having a next presentation to my commissioner secretary, which have we have worked on the proximity analysis, wherein we have shown that this much population is being catered by this hospital, because that is proximity analysis, because this is the hospital and how much near the population is within 1 kilometer, within 2 kilometers, within 3 kilometers. So that buffering, that analysis, proximity analysis becomes very easy on with the help of fingertips if we have a GIS application with us. So if you have, if I ask anyone among you right now, so you are sitting in your rooms, how far is a nearest police station from your residence? How far is the nearest fire service station from your house? So you may be able to tell me immediately that it is 1 kilometer or it is 10 kilometer. But how much area that fire station caters? How many number of households that fire station caters? How many number of households that health center caters? What is the total amount of population, total number of population that the health center caters? So that kind of proximity analysis can be done with the help of this GIS. So we have Tobler's law. We must be knowing that what is Tobler's law. It says that everything is related by location. I see when I have to go to the mountains, I see from where water is coming, what are the trial routes, what are the vegetations there, where actually snow falls. So those locations are, they are always interrelated. Everything is related by location. For example, you can see the civilizations that came up. The civilizations came up along the rivers, because the rivers had that particular location where they could deposit the alluvium, and fertile soils were there, and they were able to grow crops. And from there the cities started expanding, the civilization started expanding. Because of that location, particular location, we were able to move. Now, just what GIS can do. See, this is a simple representation of the USGS earthquake zones. So here, two things you can get. A very important two things you will get from here. Number one, is just you want to know where you want to live. If you want to make a new house, so with the help of this map, you can easily avoid the red areas, isn't it? See, you just see this map and you just see, oh, this is very highly earthquake prone zone, so I must avoid going there. I should not make my house there, so I will shift my house to the low risk zone. So that's one thing. Another thing is very important. That's a bonus actually. That's a bonus actually. For science, you can say it's a bonus. Here you can see, if I can show with the help of pointer. Here you can see this entire zone is red, and just from a scientific point of view, scientific understanding point of view, you must be curious about why this zone, this red zone is so much of red potential earthquake area. So you will be having a lot of discussions, a lot of investigations into that area. So this map, this simple map, just showed us two ways: one, where to build my house; number two, why this area is very earthquake prone zone area. So these are just simple maps. This map is just showing the access towards the forest where you can see. So see, this is actually very simple map. Nothing, not too much details into that. Not too much technicalities into that. I This is my forest boundary in the black color, and if I want to go there, so through which area I will have access. So if I coming from the left side, so I know that through that red road I can access this area, and if I'm coming from the top, I can easily see I can access the area from that area as well. Then if we go to the right side, in the right side we'll see that there is yellow road, and people the authorities will not allow me to have access in that area. So obviously, so these things, these maps make our life very simple. That's why we use GIS. So outputs from GIS, how we can see what is GIS. So maps, the printed maps in the big format maps, having the coordinates. I'm repeating always, having the coordinates, the things that are having coordinates, they are the GIS. So outputs from GIS can be in the form of printed maps, PDF, JPG, etc. There are TIFFs, GeoTIFFs, a lot of number of databases you can see. Then spreadsheets, you can just add the data, and then you can extract the useful data using spreadsheets, maybe your Excel, maybe CSV, maybe access mod. So many things are there where you can get from this GIS. Then databases. There are huge databases that can be handled by this GIS system. So here you can see the satellite images. There are so many portals, geoportals. Just yesterday, Dr. Gauhar was showing there are so many portals showing us that there are the databases, the satellite imageries are there, the shape files are there. Entire data sets can be put on a particular system having the geographic coordinate system in place. Then files like shape files and KMLs, these types of files can be brought out from the geographical information system. Now coming to the main topic, that is quantum GIS. What quantum GIS is actually about. So it's an open source. It comes with the right to download, run, to copy. Just a second, I will just update my next speaker to be ready with the presentation. So quantum GIS. What quantum GIS gives us an advantage, a very big advantage. You must. I don't know how many of you are involved in some government organizations or private organizations where they use proprietary software like ArcGIS, Aradas Imagine, GeoMedia. There are n number of softwares you have heard yesterday. You have been listening to the software names since yesterday. So there are n number of softwares, but they have a disadvantage. Yes, you can obviously see there are a lot of means to use their software, but if we go for the proprietary software in a right way, we have to purchase it at the cost of around 14 to 15 lakh rupees per license of ArcGIS, 7 to 8 lakh rupees of Aradas Imagine, and there are academic versions as well, which cost around 2 to 3 lakh rupees, where we can get this proprietary software. And if we don't have that money, then this quantum GIS comes as a savior to us. It is an open source GIS. That means it is open to everybody. Anybody can download it. You have the right to download it. You have the right to run it, copy it, change it. Even you can do, if you know have some programming knowledge, you can use it and you can alter it, and you can then redistribute the software. The problem with the proprietary software is that if ArcGIS, I have a license of ArcGIS, I cannot give that license to anybody else. If I have the Eridas Imagine license, I cannot give that license to anyone else. But with this open source GIS, quantum GIS, you have a freedom. You have freedom of doing a lot of research. You can make your own tools and put there. So I have already told that you can download, run, copy, alter, redistribute this software. No issues, nobody will catch us. Then with the source code, users have options. See, if you have the source code means that that programming language, what has been gone into that software to make that tool, say clip tool, proximity tool, say attribute giving tool, change in the color, symbology tool. So there are lots of tools are there. You will be exploring day by day. So you will be seeing that you have that if you have that source code with you, if you have that coding language with you, you can suggest improvements, you can change things. If the shape file is not clipping the raster file properly, you can suggest improvements, you can use that code, you can modify that code, you can make improvements yourself, you can hire a professional to make change, save a software from abandonment, which are not possible with the proprietary softwares. Now they come with common OS licensing, open source licensing, licenses to run in both open and proprietary systems. So there are certain provisions under this open sourcing also where you can say that, okay, I have made this software, I don't want it to be used by certain people unless they pay for it. So they are open for both. Normally they about 99.9% of the software is open, but certain things, certain maybe some tools, say I have developed some tool for wildlife management and I don't want to make it public unless somebody pays me for it, so they have given you that option as well. Otherwise also you have an open tool for the same functionality, but maybe a little bit changes will be there. Then this comes with Apache software license, then BSD, Berkeley Software Distribution, under that act they can distribute it. Then Massachusetts Institute of Technology, they were involved with this and they have also given a free hand to distribute it. License to run in open environments, GPL. These terms are actually very important. General public licenses, LPGL, lesser general public licenses, MPL, Mozilla public licenses. So these are all the privileges you can get while using this software. I will just put a link in the chat box. Just give me a second. Uh, Here we have some terms. You can see DXF, EDA, EDA, FE concepts. So I will put in the chat box so that if you want to use these terms or learn these terms, it's very difficult to learn them, but sometimes you may use it and you have to learn them for one or other functionalities. Now coming back to my PPT. I'm sorry. So here, the QGIS project actually began in February 2002. Then this was produced by a development team, Gary Sherman, who is known as the founder of Quantum GIS. The first release was in July of 2002. The first version supported only post-GIS and had no map navigation tools or layer control. So here you can see the start from January to they made a lot of versions. So you will be always seeing that whenever there is change in version, they change it. They change the name. The Titan, Geodynam, Mitis, Minimus, Core, Span, Development, etc. So they will be changing these things off and on. So here, if you want to know about what your quantum GIS is, you just download the quantum GIS first, go to about page, and you see it will tell you about the version, which version you are using, and what actually it supports, and then what's new in this version, who are the providers, who are the developers, who are the contributors, translators, donors, etc. So you can move or you can see this general public license software. So then installing quantum, once you downloaded the quantum GIS on your system, So here you can see from qgis.org. So you can uh, download it for Windows as well as Linux platforms. So here we downloaded it for Windows. So most systems are large user base, have GIS repository, Ubuntu, Debian, Fedora. All these they support this QGIS. So Windows. So Windows installer method is you have to download the standalone installer recommended for new users. Then install Quantum GIS. Currently 1.8, I believe it is more now, because it was in previous presentation as well. Also installs current release of GRASS. Also installs Python 2.7 that runs inside the QGIS. Updates, installs, and reinstalls the software and save your settings must be done manually. So normally, whatever is the procedure with installing all the softwares, once you download, you go on saying next, I agree all the terms, and you click. It will just overwrite all the previous versions, and then it will make a new version for your computer system. So standalone method will have the geographic data abstraction library, installs libraries for SID and ECW. Then SID, what is actually SID and ECW? They have they are the geographic they are the geographic databases, you can say, and these are actually kind of spatial agreements, proprietary formats that have to be used with the GDAL. Then you can see more information about what GDAL is, geospatial data library. Then you can see all this in the GDAL organization. Then one thing comes with this QGIS is OSGeo install. This OSGeo, what it provides as an it's an installer which provides us with everything. Like it runs CYG Win type environment, that is command based environment. Then CYG provides Unix commands and environments for Windows machines. Then provides some means to easier upgrade path between the releases. The function of this OSGeo is that if whenever the new release comes, so it immediately upgrades the older version because it has a predefined path where to install and how to install. Is this actually OSGeo install? It actually is not installed on your computer. So it's a kind of a virtual path that shows you. Now OSGeo installer like this will come up. It's a virtual kind of window. It will show you what to install, what not to install. So if you want to install all these things, so you have to check check mark all these things, and it will install Quantum GIS, GDAL, GRASS, OpenEV, and UDIG, a great viewer. Actually, UDIG, you can view 3D animations in this UDIG software. Maybe we may get a chance to have a hands-on on this. Then once you install the Quantum GIS, so it will have an interface like this. So here you will see number of buttons here and there, some of them familiar, some of them not familiar. So during the course of this lecture, we will see that what are these buttons, what are the functionalities of these tabs and interfaces. So this is overall how Quantum GIS looks when we open it in a first view. So this one is known as layer window. So this red one is known as layer window. By now you all must have installed this software, and whenever this comes here, so this is a layer window. Next one is this one, this window where the map is actually displayed. So this is actually the map canvas where you can see there are a large number of maps we can display here in this map canvas. So here this one is layer window, this one is map canvas. Then here we have menus and toolbars. So here you can see file, edit, view, just like any other software. Layers, settings, plugins, database, vector, raster, and help button is there. So these are menus and toolbars. So if we right click here on the menu, so here you will see it will show us the layers, then overview, undo, redo, coordinate capture, files, manage. So whatever we want to put here, so we can check them, and we can use those panels here above. So right click the area in the menu, add panels, add toolbars. So whatever toolbar you want to add will be added, and whatever menu bar you want to add will be added here. So this is known as status bar. This one, this status bar is very important. Sometimes we ask you to find the coordinates. So the coordinate will be displayed here. Wherever you move the cursor on this map window, so here you can see these coordinates, they will change, and this will also show the level of scale where you are working. See, are you working on 1 is to 10,000, 1 is to 20,000 scale, 1 is to 50,000 scale? So these are very important points to be noted. Say somebody will ask you digitize on 1 is to 10,000 scale, so you don't know where to find it. So this is the menu, this is the bar where you will see what is my scale. So this is the coordinates, and this is the datum here. The projection system and the datum of this data set, whatever is displayed in this video, will be displayed here on this screen. And this screen, whatever is pasted here, whatever is shown here in this EPSG, it will be the coordinate system of the screen. Even though you add different projection systems for any other shapefile having different transformations, different coordinate systems, different projections, but this will remain constant whatever you have opened the first layer. So it will show the coordinates of that first layer only for the entire period of your workflow. So projections of QGIS project scale and coordinates are shown in this status bar. Now we have some basic buttons in the QGIS. So here you can see we have pan button. With the help of this hand, you can see this hand just pick and pan, pick and pan, pick and pan. So this is known as pan button. Then we have zoom in, this one, this button. So you can click on this, you can click on the system and you will zoom in. And then we have zoom out. Okay. Then we have pixel resolution. Say if we click this one, so it will just go directly to the raster pixel size, whatever the pixel resolution is there of that image. So it will entirely zoom to that particular level. Then zoom to extent. So if we press this one, so whatever, say there are 10 layers added, one is here, 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 but you are zoomed to this one layer. But if you press this button, so entire layers will come like this, and all the extent, all the layers will be visible to you by pressing this button. Then zoom to selection. So this is also very important. If you want to go to some area and you just zoom in, just click this button and just select that area and you will be zoomed to that area. So then zoom to a particular layer. Say there is only one layer. So you click this, there are 10 layers and you want to zoom to one particular layer. So you just click on this and zoom to that layer very easily. Zoom to last extent. So you are working somewhere. What happens? Suddenly you are lost. You panned the layer here and there and there, and you lost where you were actually where you were working in the previous minute or second. So what you do? You just press this button. You will go to the last extent, whatever was there. Then zoom to the previous extent. So it will go to more back, more back, more back, or it will come back to the current where you had added that. Then if we see this one, this will refresh the map. This will refresh all the layers, refresh all the map. So we use this very occasionally, not too much. So this tool is very important. One is this pan, and then zoom out, then zoom to selection, and then zoom to last extent. So these tools we use quite frequently rather than other tools. So now these are basic buttons for adding the data. So with this button we have add vector layer. So you knowing what is vector, point, line, polygon, these are vector layers. We can use add raster layer. So here if you click on this, you can add satellite images, maps, whatever scanned area, GIFs, geotiffs, JPGs, IMGs, GRDs. So there are n number of formats of raster layer you can add here. Then you can add a post GIS layer. You can add spatialite layer. So you'll be coming to know what is post GIS, what is spatialite layer in coming days. So you'll be all learning what are these layers. You can add WMS layer, new shapefile layer, then remove layer, Oracle raster, then again you can have a WFS layer. So what is WFS, WMS? I will be showing. No worries at all. So here, one more button view is there. With the help of this tool, you can identify. Then with the help of this tool, you can select. With the help of this tool, you can deselect. With the help of this button, you can see the attributes of that shapefile. With the help of this button, you can measure the distance between two or the area. Then here you can see the map tips. It will give you occasional tips what to do, how to do. Then you can add a bookmark, show bookmark annotation. For example, see why this is very important. Sometimes we ignore these things, bookmarks. This add bookmark, when you add a bookmark, what happens? Say you are working one day, or one day you found some very important spot in your working. So what you do, either you note down it on your notebook, so where and write the coordinate, and then your supervisor or your boss comes in and you show him that, sir, I want to type this coordinate and I will show you that here some extraordinary feature occurs. But if you add a bookmark, you don't need to open the books and you don't need to type the coordinates manually. Just as in Internet Explorer or Google Chrome, we add some website, just click on that website and it comes. We don't need to remember, we don't need to write. Similarly, this bookmark can be placed it somewhere, and after 4 or 5 days you get a chance. Oh, 5 days back I saw that point, I want to see that again. Then you go on searching, you are not able to find, just click on show bookmark. It will directly take you to that point which you were looking 5 days before, or even 1 month before, or even 1 year before. Then this one text, it shows the annotations associated with the features. Then saving the project, as and when we work on this project, QGIS periodically saves your as with other programs, you work on Word, you work on PowerPoint, you work on Excel. So you have to save your work periodically, because once electricity is gone or something went wrong with the project, so make it a habit to save your work frequently. So QGIS, actually you have heard about the .shp file, .dbf file, .prj file. The QGIS creates its own file as known as GQS file. It's an XML based project, just as MXT in Quantum GIS, sorry, ArcGIS, we have GQS file in QGIS, and it can be edited in your whatever favorite text editor you have. Now coming to some exercises, we have open QGIS, explore the toolbars, add some data to the map and display, use some identify features, attributes. So here you can do one exercise. You can open your laptops and open the QGIS, then roam around this QGIS software, and you just see and explore the toolbars. Now, I would before going further, I want to pick somebody. Is somebody ready with the QGIS software on his system? Someone with the system?
Yes, sir. Opening. 2 minutes.
You can
2 minutes.
share. You can share your screen.
Okay, sir.
Bhavneet, you can share your screen.
2 minutes, sir.
Because things like this will make it interactive. Otherwise you will get bored listening to same thing every day. Practical things and interaction makes the lecture very lively. हाँ बनी, वेरी गुड. सो यू कैन, नहीं हाँ, ये पूरा एक्सपेंड कर दी विंडो. नहीं ठीक है, ठीक है, नो इश्यूज, नो इश्यूज. Bhavneet, can you tell me जो ऊपर वाली जहां पे लिखा है प्रोजेक्ट एडिट व्यू लेयर सेटिंग प्लग इन वेक्टर रास्टर, व्हाट इज दिस लेयर कॉल्ड?
Hello,
Bhavneet?
sir.
हाँ,
Sir, it's toolbar and menu, sir.
very good, very good. I believe you are very attentive to the lecture. So toolbars and menus are there.
Yes, sir.
Now, uh, can you right click in this portion, in this empty portion, empty over top, in the menu, the empty side,
Oh, sorry, sir.
empty side. Huh? Can you click here? See, what are these?
So these all are toolbars that are not showing here.
Very good. So you can
Add.
open, you can close the toolbars or panels there itself.
Yes, sir.
So sometimes what happens ना, कभी हो जाता है, sorry, so there are some problems sometimes that this toolbars gets unchecked and you're not able to find it on the graphic user interface.
Okay.
So with the help of this tool, you should remember where to find that tool, where I can switch on and switch off that tool. So these are all the toolbars you have, and on the upper side you have the panels. Okay. Bhavneet, can you show me the where to see the coordinate system, where we can see the
2 minutes,
coordinate
sir.
system?
Sir, I guess here, sir.
Yeah, that is EPSG is there
Yes, sir.
somewhere.
Coordinate, sir. Ruko, sir. Wait a minute, sir. Let me open a new project. Sir, here we can show it here. Coordinate, scale,
Right. See
magnifier.
here, yeah, in the coordinate it's written. You can see the geographic
Yes, sir.
coordinate. It can be in meters if you have UTM WGS. It can be in latitude, longitude if you have lat long or GCC projection, GCS projection of your data sets. Okay?
Yes, sir.
So don't get confused if sometimes it shows in meters. So it is UTM projection, and if you want to get it shown into latitude and longitude, so accordingly you will have to click this button and you can change it. Okay. So here you can see EPSG is there here in the
Yes, sir.
lower side. So you can click on EPSG.
Yes, sir.
So
We
there
can deproject it.
it can show you what is the current framework for your project. Okay.
Sir, these all are datums.
These are all the different. See, it itself shows these are the coordinate system, and this WGS 84. This is actually datum.
Okay,
Okay,
sir.
these are coordinate references, projections, and this is the datum. WGS 84 is the datum.
Yes, sir.
So
Let
you
me
have to
connect it.
understand what is projection and what is datum. These are two different things. Use
Yes,
it
sir.
for a same file. Okay.
Okay, sir.
So you can close it.
Wait a minute. Okay.
You can close it. Anyone else?
Thank you, sir.
Thank you. Thank you, Bhavni. Anyone else ready with the computer? Hmm? I guess people are not having the systems. They are not on the systems.
Yes, yes,
Sarvan,
yes, yes.
you want to show? You can share the screen. Anyone else? Anyone else? Whosoever is willing to show the screen. Just to make the things interactive. Yeah, Purnima is there.
Yes, sir, I'm ready with my
Can you,
system.
can you can you show me the buttons where we can add data,
Uh,
add raster, add vector?
so these are the toolbars.
Hmm. Yes. And then menu is there, toolbars are there. Then
Yes, sir, this is the layer window. This is
okay,
the layer window. These
okay,
are the toolbars
okay,
and these are the coordinates.
okay. Can you show me the add vector data button?
Uh,
I showed in my PPT.
yes, sir.
Hmm. Dr. Divya. On on
Yes, 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 I am there.
slide. Can you show me the add vector, add
Yes,
raster?
yes, yes.
No, 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 from the screen. Show me from the buttons, the quick
This
one.
is this is better.
You have already added all the plugins.
Yeah.
So here on the जो आपका first और second row है, second row,
Yeah.
आपका जो second row है उसका first one क्या है आपका first button. If you hover the mouse over it, it will show what it is.
Open data source, and
हाँ,
second one is new geo package,
right,
and new shape file,
right,
new spatial light,
right.
new temporary,
Yes.
and a new virtual layer.
So these are the buttons where you can add new type of data to your window. Okay. So I will move on with my presentation. So I think I was pretty much clear. So that's why you people are also very interactive and you have been listening and you have been, I believe, learning yourself some of the things and you were easily able to show that what are the areas involved in menus, toolbars, and panels, status bars, basic buttons. Then coming to the exercise. So just this is for viewing purpose. Just I will go through the slides. I will just show you what are the functions or what are the things you can do with QGIS. So if you can open one shape file in the QGIS. So with the help of these buttons, which I already showed, pan, we will try these buttons, pan, zoom in, zoom out, zoom to layer, zoom to extent, zoom to previous extent. So just give it a try yourself. Just try to use these tools, use these navigation bars. Here you can see, here also, if you cannot find it on this menu, if you cannot find it on this menu, you can find it in the view button where you can see pan, zoom, zoom in, zoom out. So here also you can see panels, layers, overview, GPS information, undo, coordinate capture, OSM data history, OSM features. So many things are available here itself. So you see panels. So here this is your panel, and this is again in the view button where you have to click two times, but here you have to click only one time with the help of this toolbar. So you can add vector data button on top, browse to your data folder, locate it under GIS, QGIS training data. It comes inbuilt with that software, and you can add country boundary shape file to your map. If you don't see any data, please be sure to check that you're adding the shape files. So here in this drop down menu, if you click here, so you have to select the series shape file there so that you will be able to see the proper file. So once your file opens, so it will look like this, something like this. Now use the identifier toolbar, the I toolbar, and then try to click on this and try to see what it shows with the help of I. So this will be just a basic exercise you will be able to do to move around to know what are the features that can be used during the course of exercise or during the course of practical periods. Then you can add some more shape files from that folder if you have downloaded that folder along the test exercise folder. So you can see these are the features. So with the help of this, you can select the single feature. With the help of this, you can select features by rectangle. With the help of this tool, you can select features by polygon. With the help of this tool, select features by freehand. With the help of this tool, select features by radius. So you can try these. You have to try these one by one, one by one. You have to look on these features and you have to see how best they work with your QGIS. So adding vector data, it supports open geospatial layers like formats, shape files, KML files, CSV files, microstation, or map info files. So here we go on adding, clicking this button, we'll add, we'll see a file, we'll go to browse, and from browse, we'll click on this file, and here you can see a lot of files can be opened. Map info, spatial data, transfer standard, microstation, comma separated, GPS, GeoSun, generic, SQLite, ISRI personal geodatabase, ArcInfo, info, and here we have to select ISRI shapefile.shp. So once we select this file, so we will be able to see the data is added. Once the data is added, right click and select the properties. And in properties, there are different tabs to help with the data. It will show you style, label, field, general, metadata, action, join, diagrams, overlay. You can set the symbology and you can change the symbology like this. You can see this window. Once you added the data to your window, you can see this layer property window, and you can see style here, how your style looks, how you can change the transparency here. If you want to see the image below and vector data above, both you want to visualize, so you can change the transparency here. You can label features. You can check the fields. What are the attribute fields to it? Say this is a county or one country or one state. So what's the name of that state? It will be there. What is the population? What is the area? N number of attributes can be there. So it can be checked under this field. Then it has the general tool, and it has the metadata. When was it created? How was it created? Who was the agency involved? When was the survey done? So a lot of things will be there. So if you click on the style and then click on this single symbol, so you can have single symbol, you can have single color, you can have category wise color, you can have graduated color, you can have rule based color. So many options within this style box. And then you can do the thematic map preparation using equal interval, quantile, natural break, standard deviation. So here is an example. You can see equal interval maps. So we have given some equal intervals, and it is showing us the map like this. So here we can show the quantile features. So here it is showing map like this. It is the same map, just we are changing the scenario of the attributes, the themes of the attributes. The natural break classes are based on natural groupings of the data. So here you can see the same map is giving different type of thematic information to us. So this is standard deviation, same map but different type of information that is useful for me. So for you, this information may be useful. For me, this information is useful. So depending upon the needs, we can prepare the maps accordingly. Then coming to the labels tab. So you can label the features. So you can label the feature with the help of country name, with the help of population. You can keep the font size here, and then you can see you want over it, above it, right side, left side, below it. So here you can see the preview also. Whatever font you choose, whatever size you choose, you can see the preview here. And then selecting the vector data. Once you added the data here, you can select. I have shown you this example in the previous slide. You can single. If you click here on this drop down, on this very small drop down, so you will get features. So if you want to select one, just select this single feature and just click on it. So only this much will be selected. So similarly, whatever you want to select, it gets selected in this QGIS window. So you can change what you have to do. You have to open that data and you have to play with the data. You have to change the symbology of the data displayed. You have to label the features. You have to add a layer to categorize by that item. You have to make the quantile maps. You have to make the natural break maps. You just try to see the difference, what is occurring between when we make those maps. So another exercise is you open the data, you add the data again, you see the style changer, go to the style manager, and you just try to prepare this type of map with the data available with you. Here you can see with the help of this tool, you can save the style, and this will, whenever you want to use the style, just load style, then click on the load style and it will automatically come. Then here, this is the attribute window tool. Here you can see house number, shape length, shape area. So many features are there. So you just need to explore one by one. And within the course of these 21 days, all these features, how to add attribute, how to make shapefile, how to delete shapefile, how to rename the shapefile, everything will be done using this QGIS. So here you can see decimal number, you can add a column, you can add one more field, you can add the precision. Say for example, what is precision? Precision means you want to keep only three, 111. If you add, sometimes what happens, I keep on adding 111, 112, 113, 114, and by mistake it gets 1141. So one more component is added to it. So to remove that component so that the field does not accept it, so it will we will keep this precision here that beyond 3 it should not accept. Then you can create the geometry, you can update the areas from these tables. So here again, then this was about the vector data. You can add raster data. It supports OGR raster formats, geotiffs, SD grid, JPG, SID, ECW formats. We can read, but we cannot write. We can support. This support must be added. Actually, we need to check one box where we can tick this SID and ECW format so that it can be added to our maps. So geospatial data abstraction library, what is known as GDAL. I have been using this word GDAL, GDAL, geospatial data abstraction library. So it has about 128 formats which it supports, and many command line tools like convert, reproject, wrap, mosaic. This can be done with the help of this GDAL. So now, what is WMS? These are some standard terms that you will be facing in coming days. That WMS is Web Mapping Service. What OpenGIS service interface provides us? It provides us this WMS, which is a simple HTTP interface. That means it is internet-based interface where you have to prepare the maps and you can publish that map into the web. So just prepare a map and publish that map in the web. And there comes the WFS. After WMS, there comes WFS, Web Feature Service Related, which enables allowing requests to geographical features across the web platforms to independent calls. Like what happens if I want the satellite picture, so it will come from Google. If I want GIS database, it will come from ISRI server. So if I want another, it will come from Bhuvan. So web feature services, if I have that feature service of Google, feature service of Bhuvan, feature service of ISRI, I can call all the three in single platform. So, but I should have access to those services. So that is known as web feature services. So this is an example. You can see USDA. You try to connect this server on the later stage. You will copy paste this and you'll connect to this, and finally you will see it calls the service. It shows us the map and it projects it in the form of satellite pictures on your screen directly, because this service, web map service, is being provided by that agency that you put on the chat box. Then exercises, what you will do, like you will try to add some raster data, just random exercises. Just try to add raster data, just try to symbolize raster data, just try to create a hillshade. Here you can see again with the help of this transparency you can arrange. So this is the digital elevation model, and just try to see, just open it. No need to do so many exercises on it right now. Just try to open how it looks, how it sees. Just put stretch to minimum maximum, and here you can see that shapefile that has changed. See here, you see the scale ratio here. Here you can see scale ratio, Z factor, angle. If you put these values, so that digital elevation model, it will look like this. So this QGIS has so many plugins for analysis. So you can do buffers, you can do projections, you can do clips, you can do unions. During the course of these 21 days, I believe you will learn everything about this, and probably projections you are going to learn today itself. There are some things that users want to do and that it doesn't. That means sometimes I want to make ice red, but it doesn't happen because there are certain things that it won't allow you to do. Recently, I was doing one project and I was trying to make a animal movement map with the help of one of the plugins in GIS, but I was not able to do what I actually desired. So for that, we had to prepare a code ourselves and try to make that possible, that function possible. So sometimes some things may work and sometimes some things may not work. So but nonetheless it is actually a genuine competition to the proprietary softwares that QGIS is giving them. You can almost do any damn exercise or any damn project with the help of this QGIS. So you can fetch plugins. There are so many plugins available. For example, I just said I wanted to do something for wildlife. I wanted to do geostatistical analysis. I want to do network analysis. Just go to plugins, you fetch plugins, and the plugins will come here. It will be added to your library. Here you can see there are so many plugins. This open layer plugin, this is very important plugin. It shows the satellite whatever data whenever you use some shapefile. So you just use open layer plugin, it will just show the satellite image or the world over ISRI or any other Google geo database that has been created. The GIS layers will come below or above wherever you want to place in your map window. So here these are the official plugins or third party plugins. So of this QGIS, so many plugins are there. So you can manage these plugins, you can remove, you can add anytime through using QGIS plugin manager. So plugins I have actually used is GRAS, GDAL, OpenStreetMaps as extent plugin that I have already used. So what is actually the problem is with this QGIS plugin is third party. You have to make sure. I wanted to show this slide because it's very important. This slide, you have to use third party plugins at your own risk because they can be poorly documented and in many cases they may not work. These are actually not guaranteed by QGIS team not to work because they don't take any guarantee of that. So here the plugin that I won that the plugins for certain platforms that can be developers can build these are home range plugins runs on Linux and not in Windows. Developer can be paid to make or fix these plugins. Overall, all these plugins whatever I have seen up till now, they're awesome and work perfectly with me. Then you can have some exercises yourself. Today you can explore plugins, you can see what is plugin manager, how many plugins are there. You can work with open layers, you just try to download open layers tool. You can have a look at Sextant software or what it is. So you just go to QGIS plugin manager, download, you just check it and then try to install the plugin and just close it and just try to see this plugin Google Satellite Data. You can see, you can drop down here and Google Satellite, Google Map, many plugins will come directly into your map window. So these are some attribute tools. GIS is no more than geometry. There are attributes built in the database. See, you can see these n number of attributes. They can be put into this geo database. Then you can search for attributes. If you want to search directly, you can look for attributes, which unfortunately this function is not provided by ArcGIS. So this function is very good here. You can directly search an attribute here only. In ArcGIS, you have to adopt a different route or different mode. So I'll rush through my slides. I think I have already taken much time. So these are the query functions. We will be learning this just to show you that what are all the functions. This is not we are going to do all these things today. Just show you what are the functions. We can add column, we can delete column, we can calculate areas with the help of ArcGIS. So exercises we'll be doing like add, delete fields, calculate fields, select by attributes, data. So many exercises are there, so many things are there. We can create, add new data. We can see map projections that we are going to see today. There are geographic coordinate systems, there are projected coordinate systems. Okay. So you can create a new shape file. All these processes will be shown. All this process. This is just an overview. how it looks. These are some advanced editing tools. You can see these tools. You can undo, redo, simplify, add ring. Sometimes you make a bigger polygon and you want to make a lake, or you want to make some part hollow. So use these features, use these tools. Delete part, reshape feature. Say you have digitized a river like this, like this, like this. Now you have digitized the river like this, like this, like this. But unfortunately, what happened here? It went wrong. So you can use this tool, reshape tool. So with the help of reshape tool, you will digitize this, and this will get erased, and this new tool, new line will take place. So we can merge features, you can merge attributes, you can rotate point symbols. These are the functionalities of this QGIS. So you can start editing features in editing toolbar with the help of this feature, this toolbar particularly. This one, you can start editing. So multiple layers can be edited at once. So just see here, you have streams here, you have structures here. So highlight this, you'll be able to this with the help of this pen. With the help of this pen, when you select this pen will be highlighted. When you select this pen will be highlighted. So if you want to edit point, you will be editing point. If you want to edit line, you will be editing the line. So you have to be careful when you do the editing part. So which layer is activated with the help of this pen. This pen is very important, and you have to be sure whether you are editing the point line or the polygon line, or the point feature or polygon feature. So these are the attributes. Once you finish the point, you drop the point, then this window will appear, and you have to put the values in these fields. You have to write what is the description, identification, everything. Then snapping. Snapping is actually very important. What happens is we digitize a road like this. We digitize the road, and there is another road coming from here. So what we did, we left a gap here. So snapping must be on all the times, because what happens with the snapping, when you digitize this layer, when you digitize this road, so it will automatically bind this with this, so leaving no gap here, no error here. Otherwise this creates problems in building the topology, or doing the network analysis when we use roads or rivers. So these are the attributes you can change. These are some examples. So here you can see within polygon, outside polygon, above polygon, everything can be done with the help of QGIS. Then finally, whatever work you do, you can make a map with the new map composition, print composer, and it can be done. And here it has the map tools are like this. It has open, save, export image, export to PDF, export to SVG, print, refresh, undo, redo, add map, add image, add label, add scale, add shape, add arrow, move item, move content, group item, ungroup item. So many things we are going to learn in coming days. How to compose a map, how to make a very good map. So these are all the features for we select for the map. Paper size, whether we are going to make A4, A0, A3 size map. So all the things are available there. So here we'll make our map, and then we can add map elements. We all know it has a legend, it has a north arrow. We can add pictures, logos, camera shots, anything we can add to this the legend. Then we can export this map to PDF, or to a JPG, where we want to present it for the presentation, or we want to show it to some planner for a printout, a big printout. So these exercises can be done. So thank you very much. I have taken, I believe, more than the time I was given. Any questions, queries, we can talk related to that.
Thanks a lot, Dr. Majid. Any question from any of the candidates, participants, any student? Because by seeing it, you won't learn it. It's not like a movie that you'll be seeing it and you learn. Software is more you practice, more you learn. So if there is no question in the day one, I presume that you're not taking it seriously. So, anyways, we'll proceed to our next session if there is a no questionnaire from anyone.
So the next session is the more
I
practical.
have a question.
Ah,
Actually, when we select any tools, so
ah,
how we deselect? If I select zoom in, then it
ah.
will continuously zoom in.
No, not exactly. Actually, I have shown it in my PPT. See, I'll again show.
What we can do, Dr. Majid, is that we can start some of the online data to be added in the
This,
QGIS itself.
yes, yes, sir, yes, sir.
So that will make more easier to them to understand.
Yes, sir. And the next session is actually will be focused on that.
Yeah.
This was missing actually in the practicals, and so here you can see these are the tools available for you. See here.
And for the data, I am sharing the link provided by DST on their site. That many times there will be issue related to the software. So I'll be sharing it right now. So whatever exercises that will be doing it, there is a link. Maybe
Uh,
the what the trainer will give you in case you're not able to find those softwares or the shape files in your by default when you're installing it. There is a site. If you open it up, can I share my screen for a minute?
sir, I will close this, and
Yeah.
actually this is the tool where you can select. With the help of this tool you can select, and with the help of this tool you can deselect that feature.
Okay, sir. Thank you.
Okay.
Yeah, I'm sharing my screen for a minute. I'll be sharing it for a minute. Can you see my screen?
Yes, sir. Yes.
Yes, sir.
So this is the site link I've already shared in the chat box, and here there is a tutorials written, and all the basic lab exercises all are prefixed by DST. So if you go to introduce understanding GIS, there you see there is written introduction to QGIS, projection, georeferencing, image registration. So whatever option you will be selecting up, you will be getting the process to do it. There is a download PDF. If you download it, the entire operation, how you have to do, what are the steps, what do you mean by georeferencing, all the handouts are already provided by DST. So you can refer it. Maybe many times when you are having a live demonstration, some of the question will be raised up once we'll close the session. So in case there is a questionnaire, you can ask to the next consecutive day. If not, you have got a site where all the data set, all the process, their workbook, their worksheet has been given, and the same data what they have shown given you as a PDF format, the data for exercise uh, is parallelly here. So you can download the data and directly you can open the data. So both the things are available. We are training you in still. If you need some handout, you've got a handout. If you need some data, you've got a data. And apart from that, the trainer will itself provide you some data. So that is the add-on thing that I have added. Rest, Dr. Majid, please.
Thank you, sir. So after this session, we are having a session on projections and projection systems. It will be handled by Mr. Nisar. Nisar, have you joined?
Yes, sir. Am I audible?
Yes,
So
sir.
we should take 5 minute break first.
Okay, sir. Suresh, sir.
Yes, we can have. So
Sir,
right
I
now
think
it's 10, it's 3:20. We can start from 3:30. 10 minutes break for all the participants.
10
And we
minutes.
can
Thank
have
you, sir. Thank you.
Yes, sir. Thank you.
डिस्कशन. तो 10 मिनट मैं चाटूंगा इन लोगों को, तब तक तुम लोग रेस्ट करो.
Thank you.
क्योंकि मेरे को भी तो बोलने का मौका चाहिए ना, सुबह से नहीं बोला हूँ तो मेरा पेट नहीं भरता ना। जब तक मैं बात ना करूं।
ठीक है सर।
हाँ भवनीत, कुछ बोलना है क्या तुम्हें?
नो सर,
मजा आ रहा है?
सर बहुत ज्यादा सर।
बहुत। घर में देखो, अब इस कोरोना टाइम में तुम बताओ कितना फॉर्चुनेट हो कि गवर्नमेंट ने आपको ऐसा दिया है जहां की आप कहीं भी नेगेटिव थॉट नहीं है आपके दिमाग में, पूरे दिन प्री ऑक्युपाइड रख रखा है हमने। तो ना आप टीवी पढ़ रहे हो, ना आप न्यूज़पेपर पढ़ रहे हो,
यस
कहीं
सर,
भी हिल नहीं पा रहे हैं एकदम से।
यस सर, थोड़ी पॉजिटिविटी हो रही है सर इससे।
यस। अब पूरे दिन आप करोगे, फिर अगर नया सॉफ्टवेयर है तो पूरी रात भर अगर प्रैक्टिस करो। और सबसे
यस सर।
बड़ा इसमें एडवांटेज है वर्क फ्रॉम होम, जो ये ऑनलाइन हो गया, तो आपको कहीं बाहर निकलने का भी नहीं है, तो घर वाले भी खुश रहेंगे कि
हाँ
आप
जी
कुछ
सर।
सीख रहे हो। और ये जिंदगी भर अगर ये सीख लोगे, मैं तुम्हें बता रहा हूँ, सिर्फ ये सॉफ्टवेयर, आने वाला जो जमाना है ना, वो प्रोप्राइटरी सॉफ्टवेयर का नहीं है। वो आने वाला, ठीक है, जिन्होंने, जैसे हम लोग पुराने थे, हम लोग करके और 10 साल निकाल लिया, उस समय हमारे पास ऑप्शन नहीं था, उतना पॉपुलर नहीं था। लेकिन अब जितना इसरो पॉपुलराइज कर रहा है, जितना गवर्नमेंट ऑफ इंडिया अब कंपलसरी कर रहा है, तो आने वाले दिनों में ये प्रोप्राइटरी सॉफ्टवेयर ना ऑब्सोल्यूट हो जाएंगे इंडिया में। और हर कंपनी अब बोलेगी कि बिकॉज की अब ये जो QGIS है ना, इसमें दोनों ऑप्शन है। सबसे ब्यूटी क्या है कि दूसरा कोई सॉफ्टवेयर खरीदते हैं तो ArcGIS अलग से करो, इमेज प्रोसेसिंग अलग से करो, उसमें
यस
तुम
सर।
अपना कमांड लिखना चाहते हो पाइथन में स्क्रिप्ट, वो भी पॉसिबल नहीं है। लेकिन जैसे QGIS आता है, एक तो सॉफ्टवेयर की जरूरत नहीं है, क्रैक वर्जन ज्यादातर जो भी आदमी यूज करता है वो तो इलीगल है ना। हम लोग ArcGIS या एडा जो यूज करते हैं, अगर कोई भी करता है, हम लोग तो उसको प्रोहिबिट करते हैं, हम लोग उसको डिमांड करते हैं कि कोई भी आप क्रैक करके सॉफ्टवेयर यूज नहीं करेंगे। लेकिन बहुत लोग बाग करते हैं। तो प्रॉब्लम क्या हुआ, क्यों इतने ArcGIS एंड एडास पॉपुलर हो गया? क्योंकि जितने भी यूनिवर्सिटीज है या इंस्टीट्यूट है, तो बच्चा को ट्रेनिंग कौन देता है? बच्चा का ट्रेनिंग जब आप एडमिशन लेते हो, तो कोई भी यूनिवर्सिटी आपको ट्रेन करता है। तो जिस दिन हमने पेन पकड़ा, जैसे कैसे अपने बच्चे को हम लोग ABCD सिखाते हैं, तो जब हमने एडमिशन लिया, जब भी हमने लिया अपने टाइम में, तो हमारी यूनिवर्सिटी ने हमें ट्रेन किया ArcGIS में, हमें ट्रेन किया एडास में। तो क्या हो गया, ऑब्वियसली जब एक यूजर इंटरफेस, मान लो कि मेरी गाड़ी है, मैं मारुति चलाता हूँ, और मेरे को फॉक्स वैगन दे दिया जाए या मर्सिडीज, 4 चक्का उसमें भी होती है, स्टेयरिंग उसमें भी होती है, लेकिन आप मारुति वाला मर्सिडीज नहीं चला सकता। तो सेम चीज क्या होता है कि अगर मैं ArcGIS और एडास को कंपैरेटिव करूं, तो वो दोनों का जो मेरिट है वो QGIS में आ गया। ना आपको 1 रुपया देना है, ना आपको कोई क्रैक वर्जन करना है, और आप अपने कोड्स, अपने प्लगइन सारा फ्री ऑफ कॉस्ट, कम्युनिटी बेस्ड है। तो कहीं भी आप अगर फंस जाते हो, इन केस के काम कर रहे हो और आपको सोल्यूशन नहीं दे रहा है, तो आप लोग एक ओपन कंसोर्टियम है, ओपन जियो स्पेशल कंसोर्टियम, उसकी मेंबरशिप ले लीजिए। उसमें बहुत सारी यूनिवर्सिटी है, हम लोग पूरे राजस्थान से, हमारी यूनिवर्सिटी उस कंसोर्टियम का हिस्सा है। हम लोग उस कंसोर्टियम के नोडल पार्टनर्स हैं, ऑथराइज डीलर्स हैं, ऑथराइज चैनल्स हैं। तो हमारे थ्रू आप जितने भी लोग जो ओपन जियो स्पेशल, QGIS, सागा, इस टाइप के सॉफ्टवेयर में आप उनसे इंटरेक्ट कर सकते हो, उनको बात कर सकते हो। बहुत बड़े बड़े प्रोफेसर्स, बहुत बड़ी बड़ी यूनिवर्सिटीज उसमें कनेक्टेड हैं, और आप डायरेक्टली उनसे इंटरेक्ट करते हो, और वो बहुत ही अच्छे प्रोफेसर्स होते हैं। आज जैसे अभी आप उनको पिंग अप करोगे, विद इन 10 मिनट्स आपको वो प्लग इन और उसका जो PDF और कैसे करना है, वो सारी चीजें आपको मिल जाएगी, जो कि आपको ArcGIS और एडास में ये वाला ऑप्शन अवेलेबल नहीं है। तो अब जमाना है, एज अ यूनिवर्सिटी हमें भी सोचना चाहिए कि हमारे बच्चों को जो ट्रेनिंग देनी है, मोर ट्रेनिंग देना है टुवर्ड्स द QGIS के ओरिएंटेड में, सो दैट कि ये जो प्रोप्राइटरी का है, बहुत पैसे जो बनाते हैं हम लोग से, वो उनका पैसा बनाना बंद हो जाएगा फिर। ये मेरा बोलना है।
यस सर। सर और इजी भी है सर ये इंस्टॉल करना।
हाँ, वही तो मैं बोला ना, उसमें तो
Home
ऑब्वियसली
basic।
देखो ऑन रिकॉर्ड है, तो आई विल नॉट गो विद एनीथिंग XYZ, आई
यस
विल
सर।
नॉट से, ठीक है ना। तो मैं इसको बोलूंगा कि ये ज्यादा इजी है, बहुत कंपोजिट है, और बहुत ही बढ़िया है। मतलब आप आराम से सीख सकते हो। तो जब भी आपकी नौकरी की बात आएगी, जब आप एट लास्ट, जब आप कोई भी कोर्स पढ़ते हो, तो नौकरी चाहिए भाई, इसलिए तो पढ़ रहे हैं। या तो रिसर्च करना है, या प्राइवेट कंपनी, या अपनी कंपनी अगर स्टैब्लिश करना चाहते हो, तो खुद अगर तुम्हें ArcGIS आता है, आपको एडास आता है, आपको NV आता है, और सबसे ज्यादा अगर आपको ये QGIS आ जाता है, तो इसमें दोनों सब सारे ऑप्शन अवेलेबल हैं, रास्टर भी, वेक्टर भी, पाइथन भी, प्रोग्रामिंग भी, आप इसमें HTML फाइल, वेब जीआईएस पोर्टल भी, पोस्ट जियो सर्वर भी है। तो बहुत सारी चीजें हैं जो तुम कर सकते हो, किसी की जरूरत नहीं है आपको, आप सेल्फ कैपेबल है। आप मान लो कि अकेला इंसान हो जो अपने डिपार्टमेंट में, अपनी यूनिवर्सिटी में ये सॉफ्टवेयर जानते हो, तो आपको डरने की जरूरत नहीं है। आप जब इस कम्युनिटी में एंटर करोगे तो इसमें 4 लाख, 10 लाख, 20 लाख, 30 लाख लोग मिलेंगे जो आपको हेल्प आउट करेंगे, आपको सोल्यूशन, जब तक वो आपको सोल्यूशन नहीं देंगे तब तक वो आपका पीछा नहीं छोड़ेंगे। तो जीआईएस में सबसे बड़ा ये है कि इंडिया में मे भी इतना पॉपुलर नहीं हुआ QGIS, बिकॉज यूनिवर्सिटीज में आज भी अपने बच्चों का ट्रेनिंग हम लोग GIS, ArcGIS और ADAS में कराते हैं, लेकिन आने वाले दिनों में जैसे जैसे देख रहे हो कि आप GIS का एंट्री हो गया गेट में, GIS की एंट्री हो गई नेट CSR में, तो आने वाले दिनों में अब गवर्नमेंट जब इसको इंट्रोड्यूस कर लिया तो जरूरी से वो कुछ ना कुछ गाइडलाइंस निकालेगा, कुछ ना कुछ कंपलसरी करेगा। तो जितना जल्दी आप सीख लोगे QGIS, जितना जल्दी आप इसमें महारत हासिल करोगे, उतना ज्यादा आप दुनिया में GIS में आपको जॉब के लिए या पब्लिकेशन के लिए दिक्कत नहीं होगी। तो ये फायदा है। इसलिए गवर्नमेंट सोचो, आप सोचो कि गवर्नमेंट क्यों पैसे दे रही है और आपको ये फैसिलिटी दे रही है, क्योंकि वो एट लास्ट ह्यूमन रिसोर्स डेवलप करना है ना। आज के जमाने में अगर अनएम्प्लॉयमेंट देखोगे, जो गवर्नमेंट अभी न्यू एजुकेशन पॉलिसी आई, गवर्नमेंट इसको क्या बोल रही है कि आप उनको वोकेशनल कोर्सेज पढ़ाओ, आप उनको टेक्निकल डिग्री दो, सो दैट कि अगर 1 साल बाद भी वो पढ़ के निकलता है, 2 साल बाद भी पढ़ के निकलता है, 3 साल बाद भी निकलता है, तो उसको जॉब लग पाए। ऑन द अदर हैंड जो ऑर्थोडॉक्स कोर्सेज थी वो मोर काइंड ऑफ थ्योरेटिकल नॉलेज है। आज अगर आप देखोगे ये कोर्स का स्ट्रक्चर जो, तो फर्स्ट हाफ में हम लोग थ्योरी पढ़ते हैं, सेकंड हाफ में प्रैक्टिकल कर रहे हैं। तो आप जब 21 दिन का ट्रेनिंग ले लोगे तो उसके बाद आपको एक मतलब कुछ चीज आती है जिसके बेस में आप एक कंपनी वाले को, एक सोसाइटी को, एक रिसर्च को एक आउटपुट दे सकते हो। एट लास्ट आप एम्प्लॉयर क्यों रखेगा जब आप उसको आउटपुट दोगे, वो किसी भी फॉर्म में हो सकता है। तो ये सबसे एडवांटेज है, इसलिए आपको QGIS जो है, गवर्नमेंट चाहती तो ArcGIS और ADAS क्यों नहीं सिखा रही है, उसके पीछे लॉजिक यही है कि ये फ्री ऑफ कॉस्ट है। और कोई क्वेश्चन किसी को? अभी और 2 मिनट है जब तक मैं खींच रहा हूँ, फिर 3:30 से हमारे पास एक्सपर्ट आएंगे। हाँ जी,
I would leave sir, मुझे दूसरी
हाँ
presentation
हाँ,
है।
एकदम।
Thank you so much, sir.
Dr. Majid Farooq for his inevitable lecture on this introduction to QGIS. And we are very fortunate that from his busy schedule, he's continuously mentoring the entire 21 days this program workshop. And tomorrow again, he'll be here and with fresh lecture. Tomorrow you have a lecture from 10 and Dr. Majid Farooq will be taking. So thanks a lot.
Thank you so much, sir.
Thank you.
Thanks. तो अभी तक मैं होप करता हूं कि आप लोग को अच्छा लग रहा है।
Yes, sir, बहुत अच्छा लग रहा है।
जी सर जी।
बोर तो नहीं हुआ? ऐसा तो नहीं है कि बोर, देखो हमने ना पूरा मतलब ऐसा बनाया है, चाहते तो हम लोग आपको कर लेते हैं 1 ही 2 आदमी मिलके, लेकिन क्या होता है ना, फिर मोनोटोनस हो जाता है आदमी, फिर आपको लगेगा अरे सेम टाइप की चीजें रिपीट हो रही हैं। इसलिए हमने क्या किया ना, इसको इंटरेस्टिंग बना के रखा है कि 21 दिन बाद जब आप जाओगे ना तो आप जिंदगी भर ये 21 दिन आपको याद रहेंगे बुढ़ापे पे। वैसा है कि आपको रहेगा नहीं यार, अच्छी यूनिवर्सिटी थी, अच्छे लोग थे, अच्छा ट्रेनर्स थे, अच्छे कोर्स डिजाइन थी, और अगले बार जब भी हम लोग कोई प्रोग्राम करेंगे तो यू विल बी वेरी इंटरेस्टेड। एंड एट लास्ट सीख के जाना। तो निशार, कैन वी स्टार्ट?
Yes, sir. Am I audible?
Yes.
Okay,
Yes, yes.
okay, sir. Thank you very much.
Meanwhile, I will be introducing Nishar. He's a a geospatial scientist at Department of Space, Ecology and Remote Sensing, a part of state of Kashmir, and he'll be taking the next session. I welcome Mr. Nishar.
Is my screen visible to all?
Yeah, yeah.
Okay, thank you very much. So here we have to deal with the projections. This is hands-on session 3. So we will get familiar with projecting and reprojecting the vector and raster datasets by using QGIS software. So I have opened here QGIS software. I am using 3.16 version of QGIS software. This is open source GIS software, very beautiful software for handling the remote sensing data and the vector layers, shape files, all the data we can handle here. And this is free of cost. We don't need any license for this, and this is very easy to install. You can download directly it from Google and install it. So let's start. As we know, the earth is spherical in shape, but it is surface is not regular at all places. So due to the presence of mountains, valleys and plains, it's not suitable to perform direct mathematical calculations on it. Therefore, a mathematical surface of obsolete spheroid best fitting the irregular surface of the earth is considered as a framework of reference for measuring the locations on the surface of earth, and this is called datum. So we use datum here. That's why I talk about the datum. So if this spheroid is best fitting a particular area, then it's called as local datum. And if it is fitting the entire globe, so then it's called the global datum. For example, Everest ellipsoid, it is best fitting to the fitting to India and not to other countries, not the entire world. So it's a local datum, example of local datum. So similarly, WGS 84 ellipsoid, it's best fitting to the entire world. That's why it's called a global datum, but not exactly to India. No, it also covers India, but not only particularly India. Generally, geographic coordinate systems are associated with these datum. So if you can see anywhere WGS 84, it's a GCS system. Coordinate reference system is GCS, not projected. Projected is something different, which we call likewise. I will give the example of that. In GCS system, the measurement we can take in degrees. So these are angular in nature. Units are in angular nature. So it's very hard to measure distance, area, and other parameters by using spherical coordinates in GCS system to represent this to represent the three-dimensional curved surface on 2D surface. So here comes the concept of projection, reprojection. So in short, I can say reprojection is the conversion of Earth's 2D surface features which are overlaid on the 2D surface to convert them into the 3D into the 2D. That's called reprojection. So its aim is to convert the Earth's 3D curved surface into maps 2D surface. For this purpose, we use projection surfaces like plane, cone, cylinder. So we have different projections like cylindrical projection, conical projection, or planar projections. So after projecting the data, conversion of the projections, it is impossible to convert a curved surface to flat surface accurately. We have to compromise on some properties. Uh, Properties. For example, to preserve the shape of the feature, we have to compromise on its area. If we want to preserve the shape, then we have to compromise on its area. Therefore, projection is never accurate. So in doing GIS projections, we have to choose the projection very carefully. Which projection we are going to use, which projection is suited to our area. So in this exercise, we will do a lot of things. So then we will add the vector data, we will add raster data, we will check the projections, what actually the raster data is carrying the projection, what sees coordinate reference system it carries, then how we can, if coordinate reference system is missing, how we can define the coordinate reference system. Then if we have to change the projection, the coordinate reference system, how we can change it is a coordinate reference system from one to another, for example GCS to PCS. So for that, in DST ISGT website, on DST ISG website, we can you can download the example data there, which sir was earlier talking about, and you can get the PDF also for this exercise. I have already downloaded that. So I will add the data. First I will do, first task we will do, identify the projection system, coordinate reference system. So here's a tool that is called manage layer toolbar. From here I can add the vector data. From here vector I can also add data from this layer, add data. From here, this is the shortcut, from here also. So first we will try from here. I will go to here. I will click on history shapefile. Here is my data. So first layer I will add, that is Pune district UTM 43N shapefile. I will open, then add to the map canvas. This is the shapefile. So when I added this layer to my map canvas, so here some information came. EPHG 32643, scale here, then coordinates, scale. From here also we can identify in which coordinate reference system this is. Since these are in meters, so UTM, as UTM projection, that is the projected coordinate system, it takes units in meters. So we can say that it is a UTM projection. From here also, if we check the layer properties, what we have to do, we have to right click on this shapefile, then go to properties. Is my screen visible to all?
Yeah, it's
Yes.
Yes, sir.
the
Okay.
only thing is, the only request what Nisar I have, because the maximum of them are learners, so
Yeah, I will go slow. I will go slow. I will repeat 2-3 times every step. What we have to do after adding this vector layer, this is shapefile. So we have to right click on this shapefile, then another window pops up, then go to properties so that we can check the information, what information this layer carries. So here are different options. Here is source, symbol, label, mask, 3D. So I have to check what I am interested in. I have to check the projection, coordinate reference system. So I will click on this information. So here comes the information. Here we can see CRS, that is coordinate reference system. It is WGS 84 UTM zone 43 projected coordinate system based on WGS 84 datum. So here units you can see, these are in meters. So this is projected coordinate system UTM. What zone 43 actually means, that this UTM projection has been divided into different zones, and our area which we are living in, that's India, we are coming in zone 43. That is why it is zone 43. There are zone 42, 40, 42, 41, 40, 39, 18 different zones. This UTM zone 43 best fits to our area. That's why we here it is zone 43. So remember this projection, and this will be used in future whenever you will work on any GIS project. So most of the time, always we use this UTM projection and WGS UTM zone 43 projection as far as this projected coordinate system is concerned. By this we can check the coordinate reference system of a layer. So another thing is, if this coordinate system is missing, somehow what we do, sometimes what we do, we brought layers, shape files from other source. We download from the net, or some agencies supply us with the data, these shape files. But what happens, due to some errors, this projection is missing. It is, although it is projected or it is in some reference system, but somehow it is not there. So what we have to do, we have to define projection for that data. So what we will do, I have another layer, I will add that here from this key vector. Then I will go to here, source, I will click here. I have another layer that is called Haveli underscore Pune shapefile. I will click on this, then open, then add.
I'll interrupt, Nishar. Do all the candidates have downloaded the data sets?
Okay,
Yes,
sir.
sir.
Have you downloaded the data sets, all the
Yes, sir.
candidates?
Yes, sir.
And parallelly work with
Yes, sir.
Nishar.
Karne
Then
ke
only
saath.
you will understand. Don't see, parallelly work.
Okay, sir.
Okay. So I have added another layer, that is Haveli underscore Pune. This layer I have added. So I will do same step. Which step I have done to Pune district UTM 43 North. What I did, I right clicked on this layer, then go to properties, then I will check and same way the information, that is CRS. But here we can see that this CRS coordinate reference system is not there, although it is overlaid on this layer, but it is not there. By some error, this CRS system is missing. Now what we have to do, we have to define to which coordinate reference system it belongs. Since it is overlaid on this layer, so what we will try to do, we will add the same projection UTM zone 43 to this layer. So how we will do that? We will go to source. Here's an option that's called source. Here it is written invalid projection. There is no projection. So if there is I have already used some other projections, that's why it is in the its list here. But we have, what we have to do, we have to click on this globe here, so that it will show me every possible projection here, from where I can choose this. I can also filter the projection, I can search projection here. So what we have to do, I want to use this projection UTM 43N. So I will write here as UTM. So from where I want to search this UTM projection. Here comes a universal transverse Mercurator. From here, I have to choose this zone 43 and projection. There are different projections, 38, 39, but our zone belongs to this 43N. From where I have to choose this.
Sir, can we search by typing in the search bar?
Yeah, we can search, or you can directly search here UTM
The best way is if we go
zone
downloads and directly we select it.
43. Here it comes. When I give the full search, here it comes. WGS 84 UTM zone 43. I have to click this. Here this shows me where this projection actually lies. So this actually lies, we belong to a north area. Here this is cylindrical projection. That's why it's here based on WGS 84 datum. So I will click OK, then apply and OK. Then again, I will check the properties. Here in information, here comes the projection, UTM zone 43 and projection, and its units are in meters. So these two steps, have everybody done these two steps? Have you understood?
Sir,
Have you got this?
can you
Yes, sir.
repeat? Yes.
I will repeat. I will repeat. Okay.
Sir, I have problem.
Okay. What problem?
Sir, when I go to properties,
Okay.
then it shows WGS 84 only, not projected. It is geographic.
Okay. Which layer?
Uh, okay, I have added a vector data.
Okay.
Then
Have you added your own data or this example data?
no, own data.
Okay. Own data.
So, sir, my request will be that please, it's my personal request that if we, because many times what happens ki when you're doing your own data, it's quite difficult to understand what the error was, and it will take at least 30-40 minutes to understand the problem where you created a layer. But
Exactly.
right now, for the exercise itself, you use the data that has been given by the DST, and post if the same thing happens with your data, then after the class we can see your independent data, because when it comes to data source, especially in geospatial data, many times the origination is the main problem related to the error. So maybe we'll be discussing it and we don't know what was the main reason, and at last 30 minutes will be off. So it's my personal request that
Okay,
please
sir.
right now work on the data that has been given by DST, and parallelly, if it doesn't work, then we'll be doing it after this session. I will take your personal request. That is my personal request.
Okay, sir.
Okay, I will repeat these two steps again. First, we have to check the projection CRS system of this layer. Then after we will define projection. How these two steps we will do. So let me remove these layers by right clicking on the layer. Here is the option that's called remove layer. We can remove. Okay. Right click, remove layer. Okay. Then I will add again. Click on the vector data. I have to go to where my folder is. For example, I will show you my folder is on desktop. I will go to desktop. Then after I will click my data is here, map projection. Then double click on this. Here is my data. Here, if you will click all files, it will look like this. Since I'm looking for a shape file, here's an extension that's called shapefile.shp extension I have to look for, so that I can discretely see my data. So here's my shapefile, first shapefile, that's Pune district underscore 43N shapefile. I will click on this, then open, then add, close. This is added to my map canvas in Quantum GIS. So first step was, then after what this is the first step. I have added the data. How I added the data to the map canvas. Then after that, what I did, I checked the projection of this data set. Then I right clicked on this shapefile, that is, then go to properties. Here another window comes with different options. I have to go to this information. Here under CRS, coordinate reference system, I can see the projection of the data set and its units are in meters. Okay. Okay. Then after what I did, I added another layer. Its projection was not defined. So I added the projection. Add vector layer. Then this file, Haveli dot underscore Pune SHP file. Open, add, close. This is the file. I can turn it off, turn on, turn it off. You can see this is the shape file. Okay. Then I have to define the same way. Right click, then properties, then go to information. Here projection is missing. I don't know which projection is this, since this is overlaid on this data set. So I can say that this is the same projection which this data is carrying. So I will go to source. It's showing me invalid projection. Then go to this. Then search for the projection. Here I can use the filter WGS84 underscore UTM zone 43, or you can write UTM zone 43 so that you can navigate to this projection. Here this comes. Since I have used it earlier, so here it comes. WGS84 UTM zone 43. Our region belongs to zone 43, and I will click here, then OK. Apply, then OK. Then right click on this. I will check again. Have I added correctly the projection to this data set? And here it comes. WGS84 UTM zone 43, and apply and OK. I can here also see coordinate. Coordinates are in meters. It's not in degrees. If it were in degrees, it was in degrees, then it would have been GCS system. This is a scale, and here I can check it. Check here also the datum 32643. Here also it's in UTM zone 43. UTM zone 43 coordinate system. So these are the two steps.
Yes, sir.
Two steps. Have you understood?
Yes, sir.
Clear to everyone?
Yeah, everyone please confirm. Everyone please confirm.
Yes, sir. Clear.
Okay, okay. So we will move on to the next step. So our next step is reprojecting a vector layer. Since we are dealing with vector layers, these are both these layers are vectors, vector layer, that is shape file. So what we have to do, we have to reproject, convert the data shape file into some other projection. For example, if we have data in GCS system, we have to convert this into coordinate this projected system, PCS system. So I will add another layer that's called places district WGS84 shapefile. I will add from here, then click on here. This is the shapefile, and open, add, and close. This is a point shapefile. Places Pune district WGS84. I will check properties of this layer so that this step will be repeated. How we can check the projection of a data set. So I will right click here, then properties, then go to information. Information is already selected. This data set in WGS84 geographic. This is in geographic system. So what I want, units are in degrees. So what I want to do, I want to convert this. That means reproject, convert from one projection to another projection. I will convert this data from WGS84 to UTM projection. I will close this. One way is the how I will show you the one way. There are different ways by which we can reproject the data. Since if you are a beginner, you have to remember one way how we can reproject. Then after once that is clear, then after whatever you try another ways. Otherwise you will get confused. Either we have to do from it here, either we have to do from it here. So simple and easy way is I have to right click on the shapefile. Then here is an option called export and save as option. Right click on the shapefile which I have to reproject. Then go to export option. Then save feature as. This window comes. Save vector layer as window comes, and format of this shapefile is this data set is shapefile. So I want to save this also in shapefile, so it will be same. Then after I have to name the file, what I want to rename this file. So I will rename it here. Go to three dots here, browse. I will browse to my folder. I will keep this in the same folder. For example, map projections here, or I will make another folder here. Not necessary to make a folder. I am making for, if you want to make a folder, you can make. If you want to take this outside, you can. Folder. I will name it as output. double click. Then here I have to choose the extension, that is history shapefile, which I already choose. Then name, I will rename it as places underscore Pune underscore UTM. Name you can name it by your choice. Since I am naming it like this, so that I can remember in which projection, which data set I have converted from which projection. UTM zone 43 N. Okay, save. Then okay, this file is added, which I have reprojected from WGS 84 GCS to PCS, that is UTM zone 43N. Then I have to check the projection. Same step. First step, I have to repeat. Right click on the shapefile, then go to properties, then information. Here under CRS, it is WGS 84, not this one. I can remove this layer. Okay, I will do it again. I think I forgot to mention the projection. Save as. Here I will rename it again. Here I had to mention the projection, which I forgot to mention. It is WGS 84, that's why it came under the same projection. So here I have to select the projection. So I will choose, I have to change it from WGS 84 to WGS 84 UTM zone 43 projection. I will click here. Previously it was in this projection, global data, GCS. Here this box indicates that this projection covers the entire area. India is here, and how much area it covers. That's why it's called global data. So I have to convert from this GCS to PCS, that is UTM. This UTM is a cylindrical projection. So I will select this, then, or I will filter here so that it will come here, then select. These are previously used projections here. That's why I'm choosing it from here. You can choose it from here also. Okay. Then, okay. Here my data comes. Then I have to check
can
the
I ask one
property. Okay. Tell me. Ask please.
Sir, in a production window, there is showing a script. That is a Python script for the projection.
What? Repeat again.
Sir, in projection window, where you're defining your projection for the vacuum file,
Yeah.
there is a script available in the window. Can you please?
Here in this window.
No, sir, where you are projecting your vector file.
When I am reprojecting my data.
Yes, sir.
When I am reprojecting data, I have showed you option. You go to, you right click on the layer, then go to export, then save as option. By this way, you reproject the data. Later on, I will say,
Sir, can you please click on again, please?
Yes.
Can you please click on same option?
Okay.
Again.
You want to repeat? You want me to repeat this step?
Yes, sir. Yes, sir.
Okay,
Save feature as.
No problem. I will remove this layer. I will show you again. I will make another layer. I have to reproject this layer. Places Pune district WGS 84 layer. I will right click on this, then go to export. Right click on this, go to export, then save as. Right click on places Pune district, then export, then save as. Click on this. This window comes. Here I have to choose the extension format, in which format I have to save. Since this file is in shapefile, I want this same file in same format. So another file which I will make from this. So S3 shapefile will be this. I have to choose the name. If I will directly type name here, then this will go to the default folder of the Quantum GIS. Since I want to know that where I have saved this file, so that I will browse here. I will click on three dots, then go to in which folder I want to save this. I want to save this on desktop. You can save this on any drive you want to. Desktop, then map projections. I have made here the output folder. So I will type the name of the layer here. If I will name it as same way, this will a message will come, a pop-up will show me that already with the same name already a file exists. So I will change the name. I will put here as underscore, so that it will be a little bit different. Then I have to choose the projection. In which projection I have, this is the default projection of this WGS84. I have to convert this projection from WGS84 to UTM projection. So I will click here, or I will click here. These are the recent projections which I have used. Here, from here, I can also choose. Or if they are not there, these projections I can't see WGS84 UTM zone 43 here. I can choose it from here also. So
Sir, here is the option where left side corner down. This is a Python. No, sir. So click on CRS option again. CRS option. Yes. No, sir. Select any product. Then it will come.
yeah.
No, sir. Now it's not coming.
Maybe you might have some problem with your.
No, sir. It's visible on your screen also.
Okay. This one.
No, sir. Globe option right side.
This window.
Yes, sir.
This in yellow color.
Sir, I think it's in Java.
Yes. Yeah. Right side. Not visible right now.
This one. This one.
No, sir. Last time it was visible. Sir, can you please click on the globe button on available on the CRS?
ऐसा है ना मुजाहिद
Yes, sir. Yes, available now. Sir, it's available.
आ जाएगा इसलिए मैं बोल रहा हूँ ना कि आप ना इंस्ट्रक्टर को ना थोड़ा सा ये दे दो स्पेस, जैसे नहीं तो फिर एक ना बड़ा दिक्कत
Okay. No issue, sir. Okay.
क्योंकि एक बार तुम कर लो, एक बार क्या होता है ना, आता नहीं, अगली बार करोगे ना, प्रोसेस समझ जाओगे, फिर तुम करोगे ना तो हो जाएगा। नहीं तो बहुत बार क्या होगा ना कि वो तुम्हारे में सिस्टम में क्या हो गया पर्टिकुलरली उस पॉइंट ऑफ टाइम, जैसे अभी अचानक से आ गया ना, तो सॉफ्टवेयर बहुत बार यू हैव टू गिव टाइम एंड स्पेस एंड योर इंटरनेट, जो तुम्हारा कंप्यूटर का जो प्रोसेसर स्पीड पे भी डिपेंड करता है।
You are talking about the message that comes in yellow text. This message.
No, sir. Can you please click on the
सर ये वो वाली की बात कर रहे हैं जब प्रोजेक्शन करते हैं तो आप दिखाते हैं।
Yes, click on this.
ग्लोब आता है।
Click on this.
इंडिया पे करते हैं।
Yes, sir. This one.
प्रोग्रामिंग
This one, left side corner. Down side.
This one.
Down side. Yes, sir.
This is data.
This is the Python script for the datum.
This is actually the conversion factor from WGS84 to this projection system. How this datum actually, this is the predefined by the script for this projection. You have nothing to do with this.
Okay. Thank you, sir.
So what we are interested in, reprojecting the data. We have to convert from this WGS84 that is defined projection of this data set. We have to convert GCS into PCS. So WGS84 is one of the GCS coordinate reference system of this data set. So we want to convert in the projected coordinate system. From the projected coordinate system, we want to choose this UTM zone 43 projection. So in India, everywhere in India, in every place, we are using this coordinate system, UTM Zone 43 projection. We have another projected coordinate systems also, that is Lambert conformal conic. We use also this, but this is more reliable projected coordinate system in which we can do calculations, area calculations, distance measurements very easily, and that comes most probably very accurate.
Thank you, sir. Thank you.
So I will choose this projection. If since I have used quantum GIS, GIS, I used to frequently use quantum GIS. That's why I have used these projections. It comes in recent projections. Maybe if you are using quantum GIS first times, these projections are not added here. So you have to search these projections from here. If you will filter, or you have to go search it here. If you will type here, for example, UTM Zone 43, like this, it will come here. Okay, then okay. So this is my newly generated shapefile. I will check whether this data set has been reprojected from WGS 84 GCS projection to UTM projected coordinate system. Properties, right click on this, then properties, then go to information. This one. Under CRS, it is UTM Zone 43 projected. So that means this projection, this step we have completed. This data set has been reprojected from WGS 84 to UTM Zone 43 projected coordinate system. So this was third step. So this was all about if we deal with the vectors, that is shapefiles. How we can check the projection, how we can define the projection, and how we can reproject the shapefile from one projection to another projection. Now, we sometimes what happens, these things we have to do with rasters also, that is satellite images, as georeferenced maps, or whatever data which comes in raster format, continuous format. So we will do same thing to the raster also. So we will remove all these layers, or you can keep these layers here. So, or you can check off these layers. Okay. Then we have to add the raster layer. So we will add from here. This is the shortcut key. From data layer toolbar, we can check add raster, or Control-Shift-R is the shortcut for this adding a raster. Or we can add from here also, from layer also, add layer, then go to same icon is shown here also, and here also, add raster. From here also we can add this. Now if we'll add from here or add from here, it's one the same thing. We will add from here, add raster, then go to this, click on this three dots. This will browse where I have to locate my folder where it is. It's in desktop. Then go to this ISGET here. Then here I have to look my raster file. So my raster file, it is as I have to check the extension. Its extension must be IMG or TIFF, GeoTIFF. So here I can see this one shape file is, one raster file is this, and another file is this .tiff. This is my raster file. These are shape files. So, or I have to click here, GeoTIFF extension. If I will click G, then it will, these only raster files it will be displayed. So I will add this raster file, open and add, close. So my raster file will be, if it is not visible on your data frame, since I have used another shape files with different projections, they might be on some another location on this map canvas. To zoom this layer to here, what I have to do, right click on the same raster file, then zoom to layer, it's displayed here. Okay, this is the raster file, satellite image, most probably one band image. So I will do same step. First step, I have to check the projection, coordinate reference system. I have to check. So what I will do, right click, then properties, go to information here. This CRS is not defined. Its coordinate reference system is not defined. So I have to first define the coordinate reference system of this data set. So here it also shows the other statics of this raster data, bands, etc., which you are going to learn in your future exercise. We are right now dealing with this CRS. So its format is GeoTIFF. So what I have to do, I have to define the projection of this data set. So I will do the same step, step number 2, how I will define the projection. I will right click, properties, then go to source. It is showing me invalid projection. That means projection is not defined. I have to define the projection. I will click on this globe, then add the same UTM projection. Then OK, apply, and OK. I will check properties, information, projection is added, UTM projection. Now I will show, once I have defined the projection of this raster dataset, this projection which I added to this, if I will remove this layer, the projection I added to this raster dataset, it will again show me invalid, because it is temporary for viewing purpose. It's showing me, but it's not permanent. So what I have to do, if I want this defined projection should be permanent with this data set, should stay permanent with this data set, I have to save this data set. So how I will save this raster data set? So what I will do, I will right click on this shape file, raster data set, then go to export option, same steps. Previous steps are being repeated so that you can remember them correctly. Export, then save as. This window, save raster layer as option comes, window comes. So this is in GeoTIFF format. I have to name this raster data set. I will do browse, then go to my desired location where I want to save this data set. I will go to desktop, then my folder here, output. I will save it here and name it as, since I gave it the UTM projection, I will name it as UTM underscore KADK. Underscore Pune. This name I will give this, or you can give your name of your choice. Then save, leave rest of the things by default. Since I have defined, I want to save this in the same project. I want to save this in the defined projection which I have earlier defined. So then OK, it's added. This new raster layer is added. So properties, source, UTM zone 43 projected. And if I will see, is it showing me invalid? No, it's UTM zone 43. Now I will show you this layer before, to which I define the projection. Since I have defined it, was earlier showing me invalid, I defined the projection. Once I will remove this layer, okay, then again I will add this layer. Then check the properties. Projection is not there. It's again showing me invalid. That's why I saved this raster data set, so that the projection I define it will be permanent. Stick to this raster data set. That's why I saved this. Likewise, if you do anything, same operation with the shape files, you have to save them, so that this defined projection will be. Otherwise, you have to repeat the same thing, or you will check that I have defined the projection. You will remove, close the project, then add that. It will show again invalid projection or projection not defined. So this was defining the projection and saving the raster data set. How we can define the projection of the raster data set, that was this. And how we can save the raster data set.
Any questions?
Yes, please.
Sir,
Anyone with any question?
yes, sir, I have.
Yes.
Sir, when I'm trying to open Haveli Pune shapefile, it shows error. It's not showing on my map canvas.
What error it is showing?
Sir, Sir, it says the file is already existed, but I cannot cannot see it elsewhere.
Have you saved this file anywhere else?
No, sir.
In the same folder with same name, or you have added?
So let me check, sir.
You add to the map canvas, then zoom, right click on the
Yeah,
same.
zoom to layer, sir. I tried that.
Then zoom to layer. It will be added. Can you share your screen?
Yes, sir. Yes, sir.
You can share your screen.
Okay, sir. Sir, is it showing?
Yes.
So this is showing, sir.
The layer already exists. Are you sure you want to override the existing? This information shows that this layer is already here. You want
Yes,
to override. Click on
Yes,
yes.
sir.
Click on yes.
Okay, sir. Sir, now I've tried to zoom to layer, but
Zoom to layer.
it shows nothing, sir.
Maybe there is some problem with the shape file. You remove this layer. Now add again.
Sir, from here, no?
Sir,
I made a mistake earlier.
Yeah.
When I'm selecting this layer, by mistake, I choose geometry type to the point.
No.
And it was showing in the point. After that, it's not showing, sir.
You
polygon.
आपको इसके साथ कुछ नहीं करना था.
नहीं सर, वही गलती हो गई थी सर वो.
That means इसकी geometry might have been distorted. You do one thing. You download this file again.
Okay, sir.
Then after try to add this.
Okay, sir. Okay.
Okay.
Okay, sir.
Okay.
Thank you, sir.
You stop your sharing your screen now.
और किसी को पूछना है कुछ? मुजाहिद, हो गया आपका प्रॉब्लम सॉल्व?
Is my screen visible to all?
Yes sir, सर हो गया सर. Yes sir, yes.
Okay. So what I did, we saved this layer, raster layer, to another. First I defined the projection of this layer, then after I saved, and I told you already that why we saved this layer, so that I want to stick this UTM projection to this, so that at next time I don't have to define projection again. So moving on to next step, what we will do, we will add another raster layer from here, or from here also. Add layer, raster, then click here. I have to navigate to browse to where my data is. I will add this layer, open, add, close, then zoom to layer. This is my raster layer. So first I will check the properties. From here you can got an idea, it's in UTM projection. I will check from here. It's in WGS 84, or it's in WGS 84 projection. This is confusing because this map canvas, it has already taken the UTM projection, because the first data set I added to this map canvas was the UTM zone 43 projection. That is why Quantum GIS by default takes the projection. If you not define the project CRS, so by default the Quantum GIS, what it takes by default itself the coordinate system. So from here I can check this, so that I can keep this off. So now I don't require, right now I don't require this. So right click on this, I have to check the UTM, I have to check the CRS of this layer. So information, then again it's in geographic coordinate system, that is WGS 84 projection. So I have to reproject what this is the earlier setup I did to share files, from where I transformed or reprojected the shape file to UTM zone 43 projection, that is PCS coordinate system. So I will do same step, right click on this layer, then property, this export, then save as. Okay. So from here I have to give the name. Why I want to save this, I will save this in output folder. So I will name it as UTM underscore okay. This name I have chosen this. It's showing me this is already existing. I will click as geo underscore save. Then I have to reproject from WGS 84 to UTM. I will change the projection. So I will choose UTM zone 43 projection. Okay. Okay. So it is processing. Since this is raster data, It carries a little bit, it's bigger in size, that's why it's taking more time than the shapefile. So here comes the message that it has been successfully saved. So right click, properties, information, WGS 84 UTM zone 43 projected. So this data set has been converted from UTM zone UTM WGS 84 to WGS 84 to UTM zone 43 projection. Okay. So this was all about today's exercise regarding the projecting, reprojecting, defining the projections. So I can apart from this, I can show you few more things from where I can do same steps. I showed you from this management layer toolbar, where from I can add the data. This is for vector, this is for raster. In another way, I can do same things. So for example, I have to reproject the data. So how I can do? I can go to this processing toolbar. Is this up to now clear to everyone? Can anybody
Yes,
come?
sir. Yes, sir. Yes, sir. All clear, sir.
Yes.
Okay. Or shall I repeat this step? It's clear. Is this clear to everyone?
Is this
Yes,
clear?
sir. Yes, sir. Clear.
Clear.
Okay.
Clear.
Okay. So I will go to processing. Here's a toolbar. This is a search option for searching various tools in Quantum GIS. So what I am interested in, reprojecting. So I will search here reproject. Here comes the various tools for vector layer, that is for shape file. Here we can reproject the layer, and for raster, this is wrap option, reproject. So for if I am interested in reprojecting the raster layer, I will go to this option. I will double click on this. This wrap reproject option pops up. So I have to add select here the layer, which layer I'm interested in reprojecting. Same layer, this one, which was in WGS 84 projection. So source CRS, it's asking me what is the source, what is its original projection. So this is optional, so this is not required. If you will keep it blank, it's not required. So target is where you what projection you want to store this data set in. So I will choose from here. I will uncheck this so that it can show me this projection. So recently I used this, so quickly I will add this UTM zone for I'm interested in this projection. Or I will, if you want to convert in another projected coordinate system, so I will choose this one, Lambert. This projection also we use in our region. So it is showing me how much area this is covering. India is here, so I will choose this one. Okay, so the sampling method same, rest of the things you will keep default. So I will run the process. Task is completed. This is the layer which I have reprojected. Lambert conformal conic. Since I didn't give the path where I want to store this data set, so Quantum GIS stored in its default folder. So I can export it from here where I want to save, or you can go again to this. Here I want to mention the path where I want to, after choosing this projection, Lambert conformal conic, then output, here's a nearest neighbor, then output. Here I have to mention the path. Target CRS. Okay. Here, saved file. This is the path. This one, reprojected. Here, save to. I will write it as LCC, position Lambert conformal conic. What if? Okay, now run. Task completed. Okay, you can close this. So this is the layer Lambert conformal conic projected. Earlier I showed you if I will not mention the path, so it will be stored in this default location. C users, sysdip, app data, local temp, processing. This one, this is a default folder of Quantum GIS. It has made. So this is the path of this file. C user sysdip one desktop, where I have saved this map position, then IGET GIS 02 data output LCC geo. This one, this raster file. Okay. So likewise, we can do with, reprojection with the layer also, for vectors also. So from here, I have to give the input. For example, I want to reproject this one, places Pune, which I earlier reprojected it from here, save as option. By save as option, I will reproject it from here by this option using processing toolbar. So I will show it again. I double click it on this reproject layer, then input as this one, then I have to choose the target to which projection I want to. Again, I will use now this projection, or you can choose this PCS coordinate system. I will choose this one, then OK, then project where I want to save this, save file to, then go to my desired location where I want to save this as. I will click as LCC places underscore Pune. Okay, save and run. So task is completed. So if I will see the zoomed layer, this is my shapefile. So I will check the properties, right click and information, Lambert conformal conic projected. So by this way, we can reproject data through processing toolbar. Earlier, I showed you how we can reproject data set using manage layer toolbar, where I used the save as option. So now I showed you how to reproject the data using this processing toolbar, which I added from here, processing toolbar. So Another way we can reproject the data. If I will go to this vector, if I have to reproject vector, then data management tool from here, reproject layer, the same tool will come. From here I can, this is the same tool which I have selected here by searching. If you don't know the path where this tool exactly is, you have to do, you should have remember the name of the tool. You have to search it here, then search it. For example, reproject, comes automatically. Okay, it's the same tool. So same tool, you can find it here, vector, raster, for raster, for vectors, then go to reproject. Here, from here also you can do the same task which I earlier did. And for rasters, you can go to, click on rasters, then go to projection, then wrap projection, same tool which I found from here, processing, search it here. By this way you can do the same thing which I earlier converted WGS 84 to LCC, Lambert conformal conic projection. So this was all about today's lecture. One more thing that is mentioned in your exercise, that is the fly on the use fly option for use projection. You project projection. So for what we have to do, for that we have to use another new project. We will close all this, click on project, then new, yes, discard all. I will close this all. This is my new project. So I will go to project properties, project, then project properties. So here comes the option. In some older versions of Quantum GIS, here it is written use of on the fly option. Now in latest versions, this has been renamed. It is written like this: project coordinate reference system, no CRS or unknown non-earth projection. So what I will do, I will keep this off, apply, and okay. Here you can see this data frame or canvas, map canvas, it doesn't have been assigned any projection, so it's blank. So now what I will do, I will try to add the data. I will add a vector files, click on this, then here is my vector data, these shape files, select both these, Pune district UTM 43 and WGS 84, which belongs to different coordinate systems. Open, add, close. You can see earlier when I added the data, that data straightly I got that data here in this view. It was here. Now it's here. This is because the data frame is not been assigned any reference system. So when I added the data, so it itself got projected or temporarily got projected to this place. So if I will click here, it will this full extent, then it will come here. So you can check this option, properties, then click off, okay. So by this we can close the projection reference system of this data frame. Or you can, if you want to start a new project, you can, by your choice, in which projection system you are interested in, you can add the that CRS system to that project. So this was that means on the fly option, or this Quantum GIS, when I first added the any layer, it automatically if those data sets are in different coordinate systems, it automatically projects, not reprojects, just projects temporarily those layers so that they can be visualized. This is just for visualizing purpose. But this is not, but it doesn't alter any projection system of the data set. Is this clear to everyone?
Yes, sir.
Okay, so this was all about today's exercise. If anybody among you wants to do or wants to add data or try to check the projection or want to reproject the data, he can do this.
Sir, sir, I've re-downloaded the data, but it's still showing the same problem, sir.
Okay, you downloaded the fresh data, you extract the data and show me how you are adding the data.
Okay, sir. Wait a minute.
The main problem is while he's adding, that time he's not selecting the data.
Okay, okay. You show me.
Wait a minute.
Sir, if manual is provided, then it will be better.
हाँ जी श्रवण जी बोलिए।
अगर मैनुअल कोई उसमें होगा कि जैसे इसके बाद ये करना है, इसके बाद ये करना है, वैसा करके एक अगर नोट दे देंगे तो ज्यादा अच्छा रहेगा।
तो सर इसमें ना मैं बता रहा हूँ
That is already in your PDF.
या जो मैंने ये साइट
can I
लिंक
start?
दिया ना, जो आपको अभी साइट लिंक दिया मैंने,
ओके सर।
इसमें रुके मैं एक बार सर एक बार स्क्रीन भावना ये एक बार स्क्रीन छोड़ो ना, एक बार स्क्रीन छोड़ो।
ओके सर, ओके सर।
मेरा स्क्रीन दिख रहा है?
यस सर।
है ना? ये देखिए स्क्रीन है। मैंने गूगल में क्या कीजिए, कुछ नहीं करना है आपको, गूगल में जाइए IGET लेवल DST टाइप कीजिए। जैसे करेंगे ये पेज खुलेगा, यहाँ आप इसको क्लिक कीजिए। जैसे इसको क्लिक करेंगे ना, यहाँ बहुत सारी चीजें दी हुई है, कौन कहाँ हो रहा है, क्या चल रहा है। यहाँ अंडरस्टैंडिंग GIS देंगे, तो ये जितने भी हम लोग एक्सरसाइज कराएंगे ना अभी, ये एकदम फेज वाइज लिखा हुआ। जैसे आज आपका इंट्रोडक्शन टू QGIS था जो डॉक्टर माजिद ने दिया, फिर प्रोजेक्शन है, कल जियो रेफरेंसिंग और इमेज रजिस्ट्रेशन है, फिर उसके बाद डिजिटाइजेशन है, उसके बाद मैप प्रिपरेशन। मतलब हर दिन जो मैंने आपको एक ये दिया है ना, क्या बोलते हैं, जो विंटर स्कूल का आया है आपके पास ग्रुप में 21 दिन का शेड्यूल, उसमें हर दिन सेकंड हाफ में हम लोग इसी से रिलेटेड एक्सरसाइजेस कराएंगे। और आप जैसे इसको खोलेंगे, जैसे कल फॉर एग्जांपल आपने बोला, जैसे आज तो हमने कर लिया, कल के लिए यहाँ पर डेटा अवेलेबल है कि कल क्या करने वाले हैं हम लोग, कल जियो रेफरेंसिंग करने वाले हैं सेकंड हाफ में। तो उसके ना डाउनलोड PDF जैसे करेंगे, यहाँ पर है कि कल हम लोग क्या करेंगे, टोपो शीट डाउनलोड करना सिखाएंगे। इसके अलावा हम लोग एड ऑन आपको अपने एंड से सैटेलाइट इमेज भी बताएंगे, कैसे टोपो शीट से सैटेलाइट इमेज को जियो रेफरेंस करना है। और उससे रिलेटेड जो डेटा सेट्स हैं वो आप जब करेंगे तो यहाँ डेटा दिया हुआ, आप इसको डाउनलोड कर लीजिए। तो हर दिन नेक्स्ट रोज क्या होने वाला है, यहाँ पूरा सब चीज दिया हुआ है। ये तो हो गया रिलेटेड टू GIS। फिर ये अगर रिमोट सेंसिंग में जाएंगे आप, तो ये देखिए डेटाबेस में सागा है। तो ये आने वाले क्लासेस में जैसे जैसे बढ़ते जाएगा, उसमें फिर ये QGIS का पूरा पैनल खत्म होगा, फिर उसके बाद ये सागा का पूरा चैनल आएगा। सागा इज बेसिकली फॉर इमेज प्रोसेसिंग, remote sensing data product, raster product. This is more kind of a GIS product, and this remote sensing saga is for satellite image classifications and filterings, जो terrain है, DEM, chain detection, ये करने के लिए। तो सारा दिया हुआ है इसमें मटेरियल, ठीक है ना। आपको लिंक मैं ग्रुप में, जो हमारा व्हाट्सएप ग्रुप में है, मैं फिर से इसको कॉपी करके और मैं पेस्ट कर दे रहा हूँ, ठीक है।
ठीक है सर, ठीक है सर।
इसके अलावा मैं डॉक्टर प्रणय से रिक्वेस्ट करता हूं कि वो जो कल वाला PPT है और जो हमने इनके लिए बनाया था, वो जितने भी बुक्स हैं, जितने भी इनके लिए जर्नल्स था, वो प्लीज व्हाट्सएप ग्रुप में इनको ईमेल कर दीजिए।
यस सर।
ठीक है,
यस सर।
ठीक है, इसको कर दीजिएगा ईमेल, और इनको बुक किताबें जितनी भी हैं, वर्कशॉप मटेरियल सब कर दीजिए इनको। बहुत मटेरियल मिलेगा, नॉट टू वरी।
Oh, okay, I asked someone to share screen.
Okay.
He was showing me how to add the data, how he's adding data. No, no, no. What you do, you click on this all files where it is written as all files. Go to again. Here it's all files. Click on shape file. Isri shape file. This one. Upar. Bas. Then click on this this one. Which one you are interested in to add. Then zoom to layer. Zoom to layer करो. Add vector. Okay, added. Is this solid now?
सॉरी सर, आई वाज ऑन म्यूट। सर एक्चुअली ये तो ओपन हो रहा है, बट हवेली वाली जो फाइल है ना, वो डिस्ट्रिक्ट वाली जो उससे थोड़ी स्मॉलर थी, वो नहीं ओपन हो रही सर।
You try it again.
ओके सर।
Zoom to layer.
Zoom to layer. Nothing sir.
Properties देखो. Define crop projection.
सर कौन सी चूज करूं सर? 43.
ये UTM. Apply.
Okay.
Okay. Now zoom to layer. Maybe this layer has been corrupted, or you have not fully downloaded this.
Sir, I've re-downloaded it, sir.
You again extract the data, then try to add this layer.
Okay, sir.
हो जाएगा नवनीत, not to worry.
I think it's PRG files.
Yeah, we'll help you out, not to worry. We'll get
Okay,
it done.
okay.
Not to
No
worry.
problem, sir.
Anybody else? व्याल, डॉक्टर व्याल, ध्यानेश्वर व्याल।
यस सर।
आपका अब बताइए, डेटा आपका जो पुराना डेटा था ना, जिसमें प्रॉब्लम था, नहीं खुल रहा था, अब वो दिखाइए।
नहीं सर, अब हो गया, उसका भी हो गया। मैंने कर दिया
मैं
उसको।
वही बोला ना कि बहुत बार ना आप जब कर लेंगे ना, तो आपको पता चल जाएगा कहाँ गड़बड़ हुआ था।
जी जी सर, वो यूटीएम प्रॉब्लम था सर, यूटीएम
हाँ।
एक्सटेंशन जो था वो।
इसीलिए ना बहुत बार ना जो इंस्ट्रक्टर है ना, पहले पूरा इसलिए खत्म कर लेगा ना तो आपकी आधा, मेरे को पता था कि अब वो प्रॉब्लम खत्म हो चुकी होगी, इसलिए मैंने उस समय आपको इंटरप्ट किया होगा। आपको हो सके लगेगा कि अरे मेरे को तो पूछना था, इसने पूछने नहीं दिया।
नो नो सर, नो सर, वैसा कुछ
लेकिन
नहीं है सर।
उसका उसका ना लॉजिक है कि अगर आगे
हाँ
आप करेंगे तो आपको खुद ही है। उस समय आप कितना भी समझाते ना आपको नहीं समझ में आता,
सर,
लेकिन अब जब
राइट
आप एक सॉफ्टवेयर समझ लेते हो ना, देखो सॉफ्टवेयर क्या है। जैसे आज ये भवनीत गुलाटी है ना, अभी ये पूरा क्योस है कि कहाँ दिक्कत है। जैसे जैसे ये आगे बढ़ेगा, जैसे जैसे इसका यूजर इंटरफेस, डेटा ओपनिंग रीओपनिंग, कैसे डेटा को फेच करना है, इसको खुद पता चल जाएगा कि कहाँ मैं गलती कर रहा था। ये खुद अभी अपना सोल्यूशन है निकालेगा ये।
Bhavneet,
ओनली थिंग इज की प्रैक्टिस करते रहना।
Bhavneet, what I observed that you are using the old version of the Quantum GIS.
Yes sir, yes sir, it is older sir.
लेटेस्ट करो, 3.22 है अभी।
3.22 अगर 3 मैं यूज कर रहा हूँ 3.16, that's also latest, not that much old, around 2-3 months old, 4-5
Sir, mine
months.
is 3.10
Okay.
.13.
अपग्रेड करो।
You go to 3.16. Okay, it's
Okay
free
sir.
of cost, you don't have to pay anything for this.
Okay sir, I will install the latest version.
Okay.
Okay sir, thank you sir, thank you so much.
Okay. Anybody else?
और कोई बता दीजिए हमें अभी, नहीं तो कल कुछ और बताएंगे इससे रिलेटेड, अब आगे बढ़ जाएंगे हम लोग।
This is the basic step, dealing with the projections. Thereafter we have to extract data, digitize, georeference,
कृतिका
और भी बहुत सारी एक्सरसाइज करनी है।
कृतिका
और प्लीज एवरीबॉडी मेक श्योर, जो सब लोग क्वांटम जीआईएस इंस्टॉल करेंगे जिन्होंने नहीं किया है, और ये जो स्टेप्स है वो रिपीट करेंगे, प्रैक्टिस करेंगे। जितना आप प्रैक्टिस करोगे उतना आप परफेक्ट बनोगे।
ऋषभ सिंह,
Yes, sir.
कोई प्रॉब्लम है?
No, sir.
ओके तो कल सबका एक असाइनमेंट है कि कल आप ना अपना फाइनल एक आउटपुट हमें ग्रुप में एक वर्ड फाइल में डाल के और भेजेंगे। आप आज जितने भी हमने एक्सरसाइजेस की है ना, इसका एक फाइनल प्रोडक्ट हमें ग्रुप में चाहिए एज असाइनमेंट। ईमेल आईडी डाल देंगे, सबको मेल करेगा वर्ड में चिपका के उसे आउटपुट अपने, ठीक है?
Okay sir, okay.
सारे पार्टिसिपेंट्स भी, बिकॉज वी वांट टू सी कि हाउ विल यू whether you are learning it, whether you are getting it. So we'll be giving you some assignment. Maybe I'll not give it today, maybe by the end of this week or maybe tomorrow cumulatively, because it is for you, it is not for us. So we want to check whatever we are putting a lot of pain for the entire day, we are making our best thing that you learn, whether you are getting it, whether you are not getting it. So that has to be evaluated. And now if there is a no question, then whether I should conclude, again I'll ask
Yeah.
again, is there any question?
ओके प्यार,
कोई भी क्वेश्चन है किसी का भी?
No, sir.
ठीक है तो
Sir, I don't have question, but sir, I request to please join me in the WhatsApp group which you have created.
ठीक है।
I'm not in the.
I've already stated to Dr. Pranay. Dr. Pranay is requested to please add the 5 participants who have been not added in our that closed WhatsApp group related to DST. So please add all those 5 participants. And I think there is a no question. So from Center for Climate Change and Water Research, on behalf of Suresh Gyan Bihar University, I would like to thank Mr. Nishar, a geospatial analyst, that he has thoroughly guided us, taught us the introduction to GIS, where we learned a lot about how to add the data, whether you're talking about raster data, whether you're talking about vector data. So the basic principle of any practical is the understanding the data, because yesterday there was a thought given by Dr. Faima Mustaq, and I too stated about that in GIS, whenever you're talking about there are two kinds of geo models that we are handling up. One was raster data and the other one was vector data. So today we added both the layers, both the data sets. So you have seen the amount of space, the amount of coverage, the amount of format, ki how the shape file look like. So when we are talking about vector, आप उसमें देखेंगे पॉइंट डेटा आया, लाइन डेटा आया, पॉलीगॉन आया, दिया है. जब हमने रास्टर किया तो रास्टर में पॉइंट लाइन पॉलीगॉन नहीं आएगा, रास्टर में ग्रिड फॉर्म में आएगा, पिक्सेल्स फॉर्म में होगा. वो इमेज हो सकता है, वो पिक्चर हो सकती है, वो आपका टोपो शीट हो सकता है, वो आपकी एरियल फोटोग्राफी हो सकती है. तो आज कम से कम ये देख के तो हमें पता चल गया कि भैया रास्टर डेटा और वेक्टर डेटा कोई पूछेगा, अब जैसे उसको राइट क्लिक करके खोलोगे तो उसकी प्रॉपर्टी हो जाती है नॉन स्पेशल डेटा. तो आज तीसरी चीज हमने सीखा जीपीएस. तो अब जितने भी हम लोग ये लेयर्स बना रहे हैं, मान लो किसी ने अभी डिस्ट्रिक्ट बाउंड्री बनाई पुणे की, और फिर हम उसमें बता रहे हैं कि सॉइल कैसा है, उसमें एग्रीकल्चर कैसा है. तो एक तो सैटेलाइट में देखा हमने, फिर सैटेलाइट से हमने वेक्टर बनाया. अब हमको चेक करना कि जो कहानी हम बता रहे हैं वो फील्ड में होगा कि नहीं होगा, कि कितना डिविएशन है अपने ओरिजिनल फील्ड से. तो उसको वेरिफिकेशन करना है, फील्ड में जाके आपको फोटोग्राफ देना है, जैसे आजकल जियो टैगिंग बोलते हैं, कि उसी जगह का फोटोग्राफ का लैटिट्यूड लॉन्गिट्यूड आएगा. तो अब बहुत जगह क्या होता है, अभी तो आप लोग मोबाइल में काम कर रहे हैं, सिटी में फोटो लेते हैं, टावर आता है, आपको एक्स एंड वाई मिल जाती है जेड, तो आपको जीपीएस का वैल्यू समझ में नहीं आता. लेकिन जब आप रिवाइंस में चले जाइए, जब आप किसी डेंस जंगल में चले जाइए या बहुत फार इंटीरियर में चले जाइए, वहां मोबाइल सिग्नल आपका काम ही नहीं करेगा. तो अब एग्जैक्ट पोजीशनिंग आपको मिलेगा कहां से, कि जहां मैं खड़ा हूं वो मैप में कहां है, और जो हमने मैप में बनाया वो सच में रियल में वहां है कि वो डिविएटेड है. तो उसके लिए एक इंस्ट्रूमेंट का हम लोग इस्तेमाल करते हैं जिसको बोलते हैं जीपीएस. तो आज जो फर्स्ट हाफ था वो आपका जीपीएस का था. सेकंड हाफ में जो टॉपिक था, जो आए थे सर, उन्होंने प्रोजेक्शन पे दिया, क्योंकि आप देख सकते हो कि कोई भी शेप फाइल या कोई भी रास्टर डेटा, अगर आपको प्रोजेक्शन नहीं पता है तो आप अपने को प्रोजेक्शन इन द सेंस कि आप ग्लोब में कहाँ स्टेशन्ड है और किस प्रोजेक्शन सिस्टम में है, क्या डेटा में, अगर पता ही नहीं है तो फिर बेसिक स्टेप यही है. अगर यही आपने गलत कर दी तो आप फाइनली चाहे पूरी मैप बना लो, पूरा इंडिया का कर लो, 2 साल लगा दो, वो सारा रास्टर डेटा, वो सारा वेक्टर डेटा कूड़े के डब्बे में फेंकना पड़ेगा अगर आपने प्रोजेक्शंस एप्रोप्रिएट सिलेक्शन नहीं किया है. तो आने वाले दिनों में और इन डिटेल प्रोजेक्शंस के बारे में बताएंगे. एंड फाइनली कैसे वो थ्योरेटिकली जो प्रोजेक्शन है उसको कैसे हम लोग प्रैक्टिकली एक प्रोजेक्शन सिस्टम से अनडिफाइंड से डिफाइंड, फिर डिफाइन से मान लो कि तुमको रिप्रोजेक्ट करना है, फिर उस रिप्रोजेक्ट से वापस आना है, वो सारा जो हमने प्रोसेस है वो आज के डेट में ये पूरा हमारा क्रक्स है. तो डॉक्टर माजिद इज हियर, विल टेक 1 or 2 minutes of his talk and thereafter I'll be concluding if it's free.
Yeah, thank you, sir. Thank you very much. I think it has been an enlightening session from morning, as you said. Uh, we had a great learning opportunities, even if I believe I am in this field for the last 15 years. So in between the lines, I also learned so many things today. In fact, from Nisa, even though he's working with me, but from him I learned so many things today, and new things, I must say. So all in all, it is a good learning opportunity for all of us, and we all should take this opportunity and take this as an opportunity so that our skills get improved in the field of GIS and remote sensing. I have attended, I believe, tens and hundreds of programs like this since last 15 years, I believe. But I think, in my opinion, apart from being myself as a trainer of this group, in my opinion, I believe this is one of the best platforms I have seen till date. So congratulations to everyone, and the program is going on nicely. Thank you for giving the opportunity to me, sir, and my team. And I believe everyone is doing wonderful. Just we need to ensure that the participants who are participating in this and trying to learn things, they should take actively part in this, and should have laptops and QGIS and Saga GIS ready with them. Thank you very much.
Thank you. Thank you for your lovely words. And as it's a prerequisite that you have to install QGIS and Saga. And today we are very confident that after completion of this course, all the participants will be very proudly saying that they know GIS. They can process the satellite image. They can create the land use land cover map by their own, and they will be publishing few papers, and they can create few maps for the society, for themselves, for the university, for the institute. And with this, I'll be concluding today's session. Tomorrow again we'll be meeting at 10 o'clock with our speaker. Dr. Majid Farooq will open up the session tomorrow morning from 10 to 12, and thereafter we have got Dr. Kiran Jalam from National Institute of Rural Development and Panchayati Raj from Hyderabad. He'll be stating about the georeferencing, its importance, and how the georeference maps are being used by Government of India for a spatial decision support system. And in the second half, again, we'll be having some practical exercises pertaining to your this georeferencing. And with this, I request Dr. Pranay Divate to end the session. Thanks a lot. Thanks all the participants. Be safe. Bye.
Thank you, sir.
Thank you so
Thank you.
much, sir. Thank you,
Thank you,
Suraj sir.
sir.
Thank you, Nishan sir. Thank you.
Thank you, sir. Thank you.
Thank
Sorry,
you.
sorry, please. There will be a link given again in that link. You have to fill up the feedback form daily, and at end of the session, by closing on the 18th day or maybe on the 19th day, the final feedback will be taken by DST. So this is the individual feedback that we are collecting from our end, and at end of the session, you have to give a positive feedback to DST too. Thanks a lot. Have a safe day. Bye.